Today, we're kicking off a brand new project. We're gonna wedge this dual overhead cam 4.6-liter Ford into this. We wanna build a smaller version of Ford's Lightning, so Project Rolling Thunder starts today, here on Trucks.
Hey guys, welcome to Trucks. Well, this is the Kevin Tate's Grocery Getter. This is my personal truck. I drive it back and forth to work, I haul stuff with it, I tow with it, and it's even been to the strip a couple of times. It's a 2000 Harley-Davidson F-150, but it is not stock. Underneath the hood is an 02 Lightning drivetrain with all of the go-fast goodies, long tube headers, and 373 rear gears. There's a custom dyno tune on it that's pulling 400 horsepower and 500 foot-pounds at the rear wheels. And at 5,150 pounds, I've surprised a couple of Mustang GTs with this thing. Needless to say, it's a fun truck to drive.
I love that truck. Now, can you imagine a drivetrain like that with that kind of horsepower and torque in a smaller, more nimble truck that can weigh anywhere between 1,500 and 2,000 pounds less? You'd have a little rocket ship on your hands, or at least a mini version of a Ford Lightning. And since Mini Lightning doesn't sound that tough, we're calling this thing Project Rolling Thunder.
Now, we were actually looking for a single cab Ford Ranger when we found our Mazda B2500, and they look almost identical until you get a little closer. For instance, look at the bedside. It's got this kind of a cool style line that we're actually getting used to. Sort of sets it apart. The doors, well, Ford Ranger. The cab, Ford Ranger. The proof's in the pudding. You check out the VIN and the sticker. It says manufactured by Ford Motor Company in the USA. So for all intents and purposes, it's a Ranger. Now inside, we got what we want, with a stripped-down, lightweight interior. But most importantly, we got the 5-speed. Now, another bonus we found with our truck is that it's wearing its original paint. And even though the paint's a little bit on the rough side, it's still better than a couple of other paint jobs hiding sins of the past. So other than some minor styling changes and Mazda badging, this thing is a Ford Ranger, which is also good news because at least on the car lots that we looked at, the Mazda trucks were a little bit cheaper. So our B2500 Ranger Mazda pickup came in at just shy of $3,000, which any way you look at it, it's an awesome start to a great project.
Now, underneath the hood of our well-used 160,000-mile pickup is a little 2.5-liter four-cylinder. Now, it runs fine, and I'm sure it would handle commuter duty just fine. You'll probably get pretty good gas mileage while doing it. But it is definitely not a high-performance power plant, and certainly isn't going to cut it for what we have in mind. So there's room for improvement, literally. Take a look around the engine. You can see the floor almost all the way around this thing. So we've definitely got space for a bigger engine. Now, if we need even more room, we can ditch the vacuum brake booster in favor of a later model Hydro Boost setup. We can remove or relocate some of these AC parts along with a couple of the fluid containers. Now, the 5-liter V8 swap, well, it's been done more than a few times, so we're going to stay away from that. We want to go with the next generation of Ford V8s, the modular 4.6. Now, they've been around long enough where you can pick up a used engine and transmission combo from a junkyard for a pretty fair price. Heck, you could even buy a complete Lincoln or even cop car and have almost everything you need to complete the swap. Now, the modular V8s, well, they're smaller in displacement, but they rev higher. And just like the Lightning engine in Kevin's Harley truck, well, they're really receptive to forced induction. Now, for stage 1 of this build, the light-duty 7.5-inch rear axle and the leaf springs are going to stay put, just to get the truck up and running. But for stage 2, those parts are going to hit the scrap pile, because that axle's not going to take any abuse from a V8, so it'll be changed out for a stronger 8.8 or 9-inch rear axle. Now, the leaf spring setup would probably be okay if we were just building a lowered street truck, but we want this thing to handle the twisties. So we're going to go with some sort of adjustable 4-link or torque arm setup of some sort, something that can plant the power and keep it there. And that'll be one of the biggest challenges we face when putting this truck together, because we're going to have big V8 power up front and not so much weight out back. Now, it's pretty apparent our 2001 Mazda spent a little bit of time up north in the Rust Belt. It was up there just long enough to put a light surface rust on all the exposed metal, but not long enough to cause any serious rot issues, so we should be in good shape. Now, as far as suspension goes, we're off to a better start up front than we were out back. We've got a short and long A-arm setup with tubular arms up top and stamped steel arms down below. We've also got the rack and pinion steering we wanted. It'll give us better steering feel and response, and also provide more room for our V8 swap. Heck, we've even got a factory power steering cooler. Now, like we just told you and showed you earlier in the parking lot, blowing the tires off of a high-performance pickup is relatively easy to do. And that's because of the extreme weight bias to the front of almost every truck out there. And our little Mazda is no different. But there's good news and bad news. Our truck comes in at just under 3,100 pounds. But if you take a look at the weight bias, it's 62% to the front of the truck, meaning that only 38% of the weight is over the rear axle. Now, ideally, you'd like to have a 50-50 weight split, front to back, side to side, and corner to corner. Now, we're never going to get there since we started with a pickup truck, but we can try our hardest to get as close as possible. So we'll just have to get creative and relocate as many parts from the front of the truck to the back and put them in the bed. And we'll just try to lighten up the front as much as possible and get this thing to hook up.
Now, under the hood, we weren't plagued with a whole bunch of messy oil leaks. However, our high-mileage drivetrain, well, it had a bit of road grime on it. And it never hurts to clean off your project before you start. Now, despite having every other tool known to man, the truck shop does not have a wash bay. So it doesn't get any more real world than the neighborhood coin-op. Now, here's some interesting trivia. Later model Rangers and F-150s already have an aluminum hood, so it gives us a weight savings head start. Get rid of all that schmutz. Catch your wheel now. Spin it, spin it. Come on, hit it, hit it. Hey, welcome back to Trucks. Let me introduce you to our little friend. Actually, not so little. This is a 4.6-liter dual overhead cam modular engine and 4R70 transmission out of a wrecked 03 Mercury Marauder. Now, we wanted to go modular for a couple of different reasons. The availability of these engines, they've been around long enough, and there's lots of them available from the salvage standpoint. Also, the high-performance potential of the 4-valve modular engines, well, it's proven itself over and over again. This one starts with a high-flowing intake manifold and notoriously high-flowing dual overhead cam heads, the same heads that come on the now legendary 2003 and 2004 Supercharged Cobras. The Marauder engine has an all-aluminum block with 6-bolt main caps, as well as high-flowing exhaust manifolds. Now, this package in a stock Mercury Marauder in 2003 kicked out just over 300 horsepower in a completely stock car. So you throw some aftermarket stuff at it, throw a tune on it, well, you can start to see the potential. Now, just in case you think we reached for this exotic engine, well, here's a list of potential donor vehicles that can give you guys a 4-valve modular. The 93 to 98 Lincoln Mark 8s, some Lincoln Continentals, 99 to 2004 SVT Cobras, Pano's Esperante, 2003 and 2004 Mustang Mach 1, obviously the 03 and 04 Mercury Marauder, and the 03 to 05 Lincoln Aviator, just to name a few. Now, obviously, the original engine and transmission are going away, but here's where you can take a page out of the Ford factory service manual and save yourself some time, because unlike an S10, the Ford Ranger cab, aprons, and radiator support, well, they're spot welded together. So just like we did when we pulled the engine out and swapped the Lightning engine into my Harley truck, well, we're going to take the cab off of the chassis. There's 6 bolts that hold it on and some engine connections. It comes straight up. You roll the chassis out from underneath it. Save yourself a lot of time. Plus, it's going to give us the opportunity to give you guys a closer look at what we're doing. Now, I know that right now there's guys talking back to their television saying you don't have to pull the cab to pull the engine, and you're right, you don't have to. However, the ability to do this type of work flat-footed and not laying on your back on a creeper, well, it's definitely worth the extra effort.
And since the air conditioning on our little Mazda still worked, well, that means it's full of Freon. And the air conditioning compressor is going to stay with the rest of the system and go up with the body when we separate it from the chassis, until we can deal with it the correct way. We may end up reusing our radiator, so we pulled it to keep it from getting damaged. And since our 4-cylinder computer won't exactly work on our new 8-cylinder engine, we pulled that as well. And separating the rest of the cab from the chassis, well, it was simple as pulling the bulkhead connector on the floorboard of the cab. Made it really easy.
And with the driver controls and harnesses separated, all that are left are 6 bolts holding the body to the chassis. Now, believe it or not, the cab is actually not that heavy. So even without a lift, with a few buddies, you can set the cab and nose on some jack stands. Now, Ford Service Tech will tell you that everything we've done is standard procedure, except the surfing.
Now, pulling the exhaust system was pretty straightforward, and we were able to remove most of the hardware with the help of some penetrating oil. But separating the downpipe from the exhaust manifold, well, that took a little heat.
Now, with a swap like this, it's kind of uncharted, so you never really know what you're going to reuse and what you're going to throw away. So we're carefully disassembling everything rather than hacking it up and throwing it in a pot.
Now, we're not really sure what we're going to do with this 4-cylinder engine and 5-speed transmission. I guess we could sell it as used parts or make a really, really fast go-kart.
Now, obviously, weight bias is pretty important with a project like this, so we're weighing everything that we pull out of this truck as well as the new components we're going to put in. The stock engine and transmission come in right at 537 pounds, which is actually a little bit lighter than we thought it was going to be. Now, with the new engine and transmission, unfortunately, we're picking up a couple hundred extra pounds, but we're also picking up a couple hundred extra horsepower, and that is a trade-off we'll take any day. From there, it becomes a balancing act and trying to effectively plant that power to the rear wheels. Get this thing balanced out. Hey, welcome back to the shop. Well, whether you're building a V8 super truck like we are, or just trying to get a little bit of extra life out of your mild-up Ranger or any other truck, if you've got composite headlights and a bit of age in your vehicle, chances are you've got oxidized headlights. Now, this is an easy problem to fix. There's several ways to do it, and we're going to show you how.
Build on a budget. Truck projects that save you time and money.
Now, like we said, this is easy. You're just going to need a few supplies, starting with some water, some ultrafine sandpaper, this is 1500 grit, some rubbing compound to polish with, and a machine to do the polishing with. Now, just like a faded paint job or a rusty piece of steel, the oxidation on the headlight is from exposure to the atmosphere. And sanding it off merely grades the road or cleans the rust off the steel, or in this case, removes the yellowed plastic layer from the top and exposes cleaner plastic that you can then polish out. Now, if we weren't just doing a demonstration on how to do this and the benefits of it, I'd obviously be doing the whole headlight, but I want to show you the difference, so we've taped off half of the headlight. Now, the mother's polish in a buffer is normally used to restore the gloss on a painted surface, but our goal with the headlight is to restore the clarity in the lens, allowing the light particles to pass through unrestricted and improving your night vision. Now, just a word of caution. Be careful around the plastic nubulas on the surface of your headlight. Those need to be there to safely aim your headlights with an aiming and aligning system, so it's pretty important that they stay intact. Now, there you go. That's a pretty dramatic result for just a few minutes worth of labor. And if you're a paint and body guy, well, you already have these supplies on hand. If you know a paint and body guy, well, you can borrow his. If neither of those situations apply, well, there's an even cheaper, even easier way to get the same result.
Well, I'm not a body guy, and I don't have that stuff laying around. What I do have is some good old-fashioned toothpaste. So we're going to show you a way to use this stuff to get results almost as good as the pro-level stuff. And the price is tough to beat. Now, it doesn't really matter what type of toothpaste you use. Use whatever you have at the house, but the grittier the better. Now, the process is the same as the other headlight, except this side's gonna smell better. Now, work it back and forth until the toothpaste seems to dry out a little bit. Now, this is gonna leave a little bit more residue than the rubbing compound would, so you're gonna have to clean it off in a couple of stages. using some water to get the big stuff off, followed up by a good glass cleaner. But the results are clear. Now, the results we got with just the toothpaste are pretty good, and they're almost as good as the results we've got with the professional level body shop supplies. And either way you go, well, it's a win because you're going to be able to see better at night and you're going to be safer. But you also don't have to replace these expensive headlight assemblies. You can just refurbish the lenses. Now, if you're going the toothpaste route, well, you can even do it without a rotary tool. Just might take a little bit of elbow grease, but at least that's free. Well, welcome back to the shop. Now, Kevin and I obviously have quite the challenge ahead of us, shoehorning this gigantic dual overhead cam 4.6-liter engine into an engine bay that was designed to house a 2.5-liter four-cylinder. Now, there's no doubt about it, it's going to be a tight fit, but we'll make it happen. Now, we'll obviously have to make new engine mounts, we'll probably have to relocate the Crossmember, and we'll more than likely have to make some other modifications as well. Now, we're going to set the engine back up against the Firewall as close as we possibly can to help with weight distribution. And speaking of weight, well, this gigantic engine and trans combo weighs in at 719 pounds, only 183 pounds heavier than the stock combination. But here's another cool fact. We're picking up 183 horsepower. That's gaining 1 horsepower per pound. And we'll take that any day of the week. Now, for stage 1, the heavy automatic transmission is going to stick around. But once we go to stage 2, we're going to swap it out in favor of a lighter manual transmission, because what we're after is the best possible power to weight ratio. We just need to make sure all the power we're making finds its way to the rear tires and onto the ground. And for that, we've got a pretty cool and unique solution. Now, if you got any questions about this crazy project we're taking on or anything else you saw on today's show, go to PowerBlockTV.com. Guys, thanks for watching Trucks. See you next week.
Today, we're making engine mounts for our 4.6-liter V8 that's going into Project Rolling Thunder. And we're making some more room in the stable for 300-plus horses. It's all today here on Trucks.
Hey guys, welcome to Trucks. Well, this is the new motivation to our latest Trucks project, Project Rolling Thunder. It's a 4.6-liter, 300 horsepower modular engine borrowed from an 03 Mercury Marauder. Now, all of this has got to fit in a happy place here between the frame rails of our 2001 Ranger-based truck. In other words, that monster's got to fit up in between the fenders of that truck. Now, we stripped the frame down to the bare bones, including pulling the engine mounts out of the Crossmember, just to give ourselves as much room as possible, because let's face it, that modular engine is just plain bigger than a typical small block Ford V8, and there is no kit for this engine swap. So it's going to be a pretty good challenge that by the end of the day, we have that giant drivetrain fitting comfortably into a compact truck.
Now, to make sure that happens, we went ahead and did a little bit of prep work. We pulled just about everything we could off the Firewall, and we pulled the plastic inner fender liners to gain clearance and to help us see what we're doing. Now check this out. We also made some relief cuts on the pinch weld at the base of the Firewall and on the trans tunnel. That way we can get as much clearance as possible to help us shoehorn that giant engine and transmission combo down into the engine bay. Now, in the past, we've had to deal with the AC system and the refrigerant that's in it by paying somebody to come out here and evacuate the system. But this time, we've got a unique and easier solution.
Now, everything in this bed liner that doesn't end up going back on our truck, well, it's going to get weighed so we can keep track of vehicle weight that we trimmed down. But this right here is what Ryan was talking about. This giant AC box is going to come in contact with the right bank giant cam cover. So we just decided to take the whole entire sealed system off of the truck. That way we don't illegally release any Freon into the atmosphere, we don't make any tree huggers angry, and if we decide to reclaim the Freon, well, we can take this whole system down to a service center and just do it there.
Now, dropping this big 4.6 down in between the frame rails is actually the easiest part of this mock-up. So we're gonna have to drop the cab down, make some adjustments, and push some things around to see what we've got to work with. All right, now there's no doubt about it. It's a tight fit, but the engine's in here. And we actually have about an inch of clearance between the back of the cylinder head and the firewall. We definitely needed to remove the heater box. And the exhaust is going to be a tight squeeze. But we got all kinds of room up here for a radiator.
Now, the throttle linkage looks like it actually might even work with the original Mazda gas pedal. The cable's just about the right length. And we got a little bit of futzing to do with the steering shaft, but the good news is it's gonna work. Here's the ultimate test. Stock hood closes perfectly. Now there is a stealth factor.
All right, now we've gone ahead and taken some measurements on where the engine is sitting right now, because we know it fits and we don't want it to move. But before we start building some engine mounts, we want to see if we can get this factory Mazda Crossmember to line up with the Mercury Marauder transmission mount, because as it sits right now, it's pretty darn close. Now the bolt holes look symmetrical, so we may be able to get away with dropping the Crossmember, flipping it 180 degrees and reinstalling it. And hopefully everything will line up. And even if it doesn't, well, the bolt holes for the mount itself are drilled offset of center, so we may be able to flip that around as well to see if it'll line up. We got a couple of variables to work with, so I think we can get it done. But even if we can't, well, it'll only take a few modifications to the Crossmember or the mount itself to get the stars to align and get this puppy bolted in. Because we don't want to spend too much time on it, because this is going to have to change around when we go to stage 2 for this build, swapping a manual. Well, I don't think that's going to work. Now, it looks like by flipping the Crossmember around, we've actually moved it too far forward. And the way it was before, well, it wasn't that far off. So I think what we can do is oblong the mounting holes where the Crossmember installs to the frame. That should give us the adjustment we need. It goes to show you, maybe try working with what you got. The solution may be cheaper and easier than you think. And it was as simple as using a cone-shaped carbide burr and our die grinder to oval the holes out. Hopefully everything will line up. Let's see if this works a little bit better.
Now, you're not going to sacrifice any strength by elongating holes, especially with 3 mounting bolts on either side. So it just goes to show you, it pays dividends to try and work with what you've got instead of whipping out the credit card.
I don't know why we didn't do that first.
The 4-valve heads have a unique port design, so we're tied to a certain style of manifold. We're going to solve this problem later and just get them out of the way for now. Yep.
All right, we're there.
Cool. Perfect. Well, with our transmission locked into place and our wood blocks holding up the oil pan, this is exactly where this engine is going to sit. Now all we have to do is fabricate some kind of a receiver for the existing engine mount, which are the factory engine mounts. And that gives us one more part that we can get over the counter and one more way to save big bucks in doing this engine swap.
Up next, we need to make just a little more room on the firewall. And later, it's a temporary drive shaft fix that'll get us back on the road. Stay tuned.
Hey, welcome back to the shop. Well, so far today, we've had a chance to shoehorn our 4.6-liter dual overhead cam engine and transmission combo down in between the frame rails of our Mazda Ranger pickup truck. Heck, we even dropped the cab over top of it to make sure it was in the right spot. Now, to get the transmission mount installed, all we did was slot the Crossmember and lock it into place. Now, we've got to make some engine mounts. The plan we've got for that is just to create a flat mounting surface for the engine mount to sit on. Now, I went ahead and cut out a cardboard template roughly the same size as the factory engine mount. Cut a hole for the mounting stud, and once I transfer this over to 3/16 plate, cut it out and drill a hole, well, we'll go ahead and install it, tighten down the nut, and tack weld the steel plate to the Crossmember. And we'll pull the engine back out, burn in the welds, add a gusset or two. We should be in good shape.
Factory Marauder engine mounts are perfect for this 4.6 swap. Now, even if you didn't use a Marauder engine, you can get these over the counter or from a junkyard, and they really make it easy.
All right, drop it down. All right, slow down. Yeah, right there. All right, lift up. All right.
With the top plate located, you can use transfer paper to make your gusset for the other side. Now we're only gusseting one side so we can have access to the stud with a fastener. After a quick double check to make sure the plates are level, Ryan burns in the gussets.
She's home.
That's cool.
Very nice.
Now, one of the coolest things about the dual overhead cam 4.6 are the giant cam covers. But unfortunately, that's also one of the things that makes it a little more difficult for an engine swap like this. But with the placement that we've got a lot of room for just about everything, including room up against the firewall on this side. But the firewall on this side, well, it's adjusted out, it's kind of ballooned out here to make room for the driver controls, steering shaft, etc. So what we're going to do is flat plate this so it matches the other side. And we're going to use the piece that I cut out as our template. Tracing around your template, give yourself 1/2 to 3/4 of an inch of extra metal. Using an electric shear, I'm rough cutting around my marking, since it's a process of cutting and trimming from this point. Now, just like selecting the correct hammer and dolly, you want to choose a forming tool that closely resembles the shape of the workpiece you're trying to create. In our case, it's a pair of duck-billed vice grips from Matco. Now, obviously, we're not trying to reskin the entire firewall. All we're after here is giving a symmetrical firewall on either side of the transmission tunnel so our giant cam cover doesn't interfere. Making some relief cuts with a hand shear allows you to easily form a curve in 20-gauge sheet metal. Once I'm happy with my rough shape, I'll start to tack it in place with rosette welds and then hammer form my way around the edge for a nice flush fit. Leveling the welds of the flap wheel is purely for cosmetic reasons, but this is a visible panel. We'll follow that by prepping with a red Scotch-Brite pad and sealing the patch. We're using Loctite black RTV sealant, but you could use an automotive seam sealer as well. The point being, you want to seal the patch so you don't have any vapor leaks or moisture leaks. Painting is pretty straightforward with Duplicolor's semi-gloss black, but here's a cool tip. If you're in a hurry like we are, you can force flash the first coat of paint. That way you're not going to get runs if you put on a heavier second or third coat.
Hey, welcome back to the shop. Now, with our engine and transmission swapped in, well, the distance between the output of the transmission and the rear axle has changed, calling for a shorter drive shaft. Now, like we told you earlier, for stage 1 of this conversion, we're going to keep the automatic. But when we go to a more high-performance stage 2, we're going to swap in a manual. So rather than buying a drive shaft now and a drive shaft later when we go to stage 2, well, we're just going to try to shorten the stalker and save a few bucks.
Build on a budget. Truck projects that save you time and money.
Now, we're going to need to swap over the Marauder transmission output onto our drive shaft. And we've showed you guys this stuff before, but this time we want to show you a couple of tools to make the job easier. Now, both these tools we picked up from Matco. The first is an air hammer attachment that drives on the yoke and drives the U-joint cap down into the tool itself. It'll save you from having to do the hammer and socket method. The second is some U-joint snap ring pliers, and it'll keep you from inventing new words, getting frustrated with needle nose. That was too easy. The impact hammer and attachment makes quick work of removing the rusted-in-place U-joint caps. Now, like we said, this is going to be a temporary drive shaft until we can move on to stage 2 and buy a high RPM, fully balanced drive shaft. But there's still a couple of things we can do to make sure this job gets done as accurately as possible. Now, to make sure we don't upset the balance of the drive shaft too much, and to make sure the U-joint yokes stay in phase, we make a mark down the length of the drive shaft. We also mark the 2 inches we're going to cut out of it. After making sure the tube is level and perpendicular to the saw blade, we can go ahead and make our cuts. Now, if you're wondering why we're not making the modification closer to the yoke, well, that's where the weights are attached, and we don't want to get into that area. Plus, the larger diameter section we're working on will just increase the weld strength. Using the red scuff pad, we'll first clean the area to make sure we get a good clean weld. The second thing we'll do is put a slight bevel on the end of the tube to make sure we get good weld penetration. Now here's another tool that's pretty handy. This is a magnetic ground clamp attachment. A few MIG tack welds will hold everything in place until we can measure for run out before the final welding. All right, with our temporary drive shaft tack welded together, we want to make sure the run out is within a reasonable amount before we fully weld it in. Now to do that, we're going to use these aluminum V-blocks and a dial indicator. Now scrubbing off any surface rust and applying a little bit of grease to where we're going to be spinning our drive shaft will minimize any rolling resistance, making it easier to turn and increasing the accuracy of our measurement. Now ideally, you don't want any run out, but a good rule of thumb is you want it less than 5 or 6 thousandths. All right, once you're happy with the run out, you can go ahead and fully weld it together. Just remember, do small sections at a time. You don't want the drive shaft to warp. Now, you can get this done with a MIG welder, but a TIG offers a little bit finer heat control. Remember, the wall thickness of the tubing is only about 1/16 of an inch. Hey, welcome back to the shop. Well, we've had a chance to install our shortened temporary drive shaft. That should be more than enough to get us through stage 1 of this build. Because like we told you, when we go to stage 2, we're going to a manual transmission. Then we'll go with a brand new drive shaft. Now, if you guys need to get a job like this done at home and you don't have the tools and equipment or the experience necessary to lay down a decent and safe weld, well, you can take a measurement, send your drive shaft off to a Driveshaft shop, and they can shorten it and fully balance it for you, for not too much money either. And now that we got our engine and transmission locked into place, we're going to roll the chassis back under the cab one more time, set the cab down, and see how much clearance we gained with our new Firewall relief.
Now, whether you use your tools as a hobbyist or you make your living with your tools, you want to be able to reach for the best. You guys have seen us use Matco's Pitbull 3/8 drive air ratchet with all its features, including more torque than any other ratchet in its class. Well, now they've got a Pitbull in quarter drive. The MT2814 is ergonomically designed with a feather trigger, an adjustable exhaust port, and an amazing 45 foot-pounds of torque, which is great for a quarter drive ratchet. So if you want to get your hands on the most powerful quarter-inch drive air ratchet, get a Pitbull from your local Matco tool distributor. Now, obviously, one of the biggest challenges for any late model EFI swap is engine management and communication, but we have got that covered in a big way, but you're going to have to keep watching to see that. For now, we're going to declare this phase mission accomplished because it fits less than 1/2 inch of firewall clearance, but that's okay because we have the bulk of the engine weight back behind the center point of the spindle, which is really going to help us balance the weight of this vehicle out. And now check this out as well. We've got nearly 10 inches of clearance between our front engine accessory drive and the stock radiator support. So we'll have all kinds of room for really effective cooling and an electric fan. And check this out too. The stock brake booster with a little bit of creative slotting is going to fit right where it's supposed to. Thanks for watching Trucks. If you got any questions about today's show or anything else you've seen, go see us on PowerBlockTV.com. See you next time.
Today, now that our 4.6-liter V8 fits between the frame rails of Project Rolling Thunder, we've got to move a few things around to make sure we can close the hood. We're even going to make our very own custom dual exhaust for this Mini Lightning. It's all today here on Trucks.
Hey, welcome to Trucks. Well, today's show is all about solving problems. And the first big problem that we had was that the anemic 4-cylinder engine in this Mazda B2500 truck, it wouldn't even get out of its own way. So we solved that problem by finding a junkyard. Mercury Marauder, double overhead cam, 4.6-liter, 300 horsepower automatic transmission drivetrain that will now, in fact, guarantee that this thing will get out of its own way.
And the installation actually turned out to be the easy part, because what we've got left is all the typical issues that pop up when doing almost any engine swap in almost any vehicle. We've got the steering to modify and relocate, we've got to finish up the exhaust system, and we've got some work to do to the heater box that we modified for clearance. We've also got to do something about this giant brake booster that's trying to occupy the same real estate. It's that giant valve cover.
So today, we're going to walk you through modifying some of the vehicle systems that Ryan listed off and hopefully pass on some tips and tricks that you can bring home and use on your project, even if it isn't a 300 horsepower Ford Ranger. Now, we needed to buy about an extra ½ inch of room to make a brake booster work with our new 4-valve super wide cam covers. We even thought about maybe going to a Hydro Boost system on this truck, since it is rack and pinion with power, and a lot of later model Mustangs live happily with that system because it's narrower. But the more we started looking and measuring, the easier this project got. Now, this is the brake and clutch pedal assembly. This is a pretty simple device. It basically sandwiches the firewall between the booster and the bracket itself. And it's bolted into the top of the cowl from the inside. Now, what we did by slotting this is effectively create our ½ inch of space so we can drag the whole assembly towards the outer apron. But slotting this is only half the story.
Now, we modified the firewall that same measurement Kevin modified the bracket, about ½ inch, because we just didn't have a ½ inch of clearance to gain by slotting this hole outward. Plus, it would make this aluminum bracket really weak. And this area's got to be really strong. It goes through thousands and thousands of pedal cycles over the truck's lifetime. Now, for a little extra insurance, we also ground down our coil covers just to make sure this thing will fit. Now, time to see if it does. And we even got clearance for a screwdriver, about ¼ inch all the way around. We're in good shape.
Now, on the other side of the engine, if you remember, we completely removed the entire heating and air conditioning system just to free up the space and see what would fit and what wouldn't. Well, as it turns out, about half of the heater box doesn't even fit. This half, that housed the air conditioning part of it. So we just completely eliminated it. We don't need air conditioning because we got the 260 air, which is both windows rolled down to 60 miles an hour. You know the drill. Anyway, what we had to do, cut half of the heater box off. Now we have a holder patch. Now, this is an easy fix because it's not like this box is pressurized. All we have to do is block the airflow off so it redirects it back inside the cabin, so we have defrost and a little bit of ventilation. This can happen with a simple patch, which starts with a template. Now, usually you can transfer the template onto something like fiberglass or even another piece of plastic and just glue it in place. But we've got something way cool to show you. This is a product called Hyperfiber from Percy's High Performance. It's lightweight, strong with a twill weave, and it's easy to work with. It comes either with the wire made into it to hold the form a little bit better, or flexible without the wire. They have a resin and a filler that are both UV curable, just like the Hyperfiber. But here's the deal. It's not fiberglass. There's no resin to mix in, there's no window of time before it kicks and gets hard, and there's no risk of over-mixing because everything you need is already in here. It stays flexible, just like this, until you expose it to UV light, which is outside. You set it outside, everybody's got access to that. But if you're in a box like us with no windows, well, it's going to stay formable until you hit it with a UV light source, like this light that they also provide and sell on their website. Step 1 is simply trimming the Hyperfiber to fit your workpiece, and we're using the Hyperfiber resin to aid in adhesion. Once you're satisfied with the basic shape, peel one side of the plastic coating off and fit your patch to your panel. Now, unlike fiberglass, there's no hardener. You have all the time in the world to fit your piece. A little bit of tape will help you lock things in until you expose it to UV light. Now, you don't need a curing light to cure the Hyperfiber. You could just set it outside and expose it to natural sunlight. Our light is available from Percy's, but any ultraviolet light source will work. There you go. harder than a frozen hot dog. And all we got to do is clean up the edge a little bit and throw a coat of paint on it. But remember, these glasses I'm wearing, they're part of the equipment. It's not a fashion statement. They're UV protective glasses. And if you get a cure light, don't even look at it. You can damage your eyes. But pay attention to a few basic rules. This is a wonderful new product.
All right, with a couple of our engine swap problems solved, we need to move on to the steering, because obviously the factory setup's not going to work with that giant hunk of aluminum in the way. Now, what I've done is drilled a small hole in the firewall, slid in this piece of brake tubing so we could line everything up with the base of the steering column, get everything mocked up. That way we can pull the cab off and get the steering problem solved. Now, to get the job done, we picked up a few parts from Borgeson. Now, obviously, the Ford steering shaft had a fairly straight shot down to the rack. But since we've got a pretty hard angle with the steering snaking around the exhaust manifold in the frame, well, we picked up one of these. This is a double universal joint with the Ford factory V-style attachment at one end and the standard double D input at the other. Now, since we're going to be running multiple U-joints, we also picked up a 3/4-inch rod end for some support and this cool Firewall bearing flange. Now, to connect everything, well, we're obviously going to have to run some 3/4-inch fully polished double D shaft. Now, since the universal joints are needle bearing equipped, well, it's not only going to be precise, it's going to be factory smooth. This double jointed piece really helps us get down to the original Ford steering rack in between the exhaust manifold and the frame. And this short section of double D that attaches to the longer section that goes up to the column needs to be supported with a rod end to keep it from flopping around under steering input.
Up next, we'll get our oil filter relocated and pick out a muffler. And later, we'll show you how exhaust tubing is bent. Stay tuned.
Hey guys, welcome back to the shop. Well, we've had a chance to make a mount for our steering shaft support rod end. And here's what we've done. We used a piece of 1.25" DOM and a 3/4-inch grade 8 nut that we basically turned down so half of it would fit inside the tube, basically made our own tube insert. Then we added a couple of plug welds and some TIG welds all the way around the circumference. This thing should be plenty strong.
Now, just because the engine fits the hole doesn't necessarily mean that the extra wear items like air filters and oil filters are going to fit as well, especially with an engine swap. Now, fixing the steering linkage introduced us to another problem that we've got to solve, which is the oil filter. And on that particular engine with its location, it just doesn't work for us. Sometimes you can get by with using a shorty filter like this guy, but in our case, no, it just doesn't work with the frame rail, suspension location, all that kind of stuff. So what we did is give Maximum Motorsports a call, and they sent us one of their high-end oil filter relocation kits. The filter mount and block adapter are billet aluminum and black anodized for a cool look. All the brackets and hardware are included, and a high-performance oil filter comes with the kit. Dash 10 AN fittings are also included, as well as zip ties, even some thread sealant for the threaded ends. They also throw in enough braided line to put this pretty much anywhere you want, and some spiral wrap to protect any of the soft items that the braided line may come in contact with. So with this filter relocation kit from Maximum Motorsports, we're certainly not compromising on any quality, and we don't have to build our truck around this. The kit comes with everything you need to relocate your filter and detailed instructions. Now, one of the hassles with AN fittings and braided steel lines is completely eliminated with the Cool Tools fixture, which simply mounts in the vise and you do a 1/4 turn press with your braided line, instantly placing it into the AN fitting. Now, the adapter mounts on the block just like a filter with an O-ring seal. So what we're going to do is mount the lines in loosely and then figure out the location of the filter when we get the cab back on.
Now, some of you guys may have noticed the exhaust manifolds bolted to our 4.6. Well, they're not the Mercury Marauder manifolds that came on it. That's because we've ditched them in favor of some that will flow and fit a little bit better. And here's what we swapped them for. These are 03 Mustang Cobra manifolds on loan to us for stage 1. And they actually give us about a 1/4 inch of clearance between it and the control arm mounting bracket. Now, for the rest of the exhaust system, here's what we have in mind. Now, we're definitely going to be using a pair of MagnaFlow heavy metal catalytic converters in the high flow variety. But as far as mufflers go, well, it's really hard to tell how loud a truck's going to be by looking at a picture in a catalog, because we want this thing to be loud but not obnoxious. After all, it is named Project Rolling Thunder, so we ordered up a few muffler choices. Now, our first option is this 4-inch round race muffler. Now, I'm guessing that puppy's gonna be pretty loud. Our next option is the 5-inch round race muffler, and the third is the more traditionally shaped 4x9 muffler. Now, all of these are stainless steel, have a flow-through design, and have 2.5-inch inlets and outlets, so we can interchange them and pick the sound we like best. Now, each cat is going to get installed in between the transmission and the frame rail, close to the exhaust manifold, because the sooner these things get hot, the sooner they start working. Now, as far as mufflers go, well, they're going to get installed in between the drive shaft and the frame rail as low and as far back in the chassis as possible to help with weight distribution. Then we'll just add some turnouts in front of this right rear wheel, NASCAR style.
And we're going to fab most of that up right here in the shop using this. Stick around.
Up next, it's a dual exhaust setup that exits out the side, NASCAR style. Stick around.
Hey, welcome back to Trucks. Well, today we're solving problems, primarily created by putting this stupid big engine into this really small truck. But we're actually doing pretty good. So far, we've got our oil filter safely relocated, our steering shaft, we've got a clear plan for that, and our heater box is patched. So now we can move on to the exhaust system. On the passenger side, it's a pretty clear shot from the manifold straight into the cat at a 45-degree angle, then back into some 2.5-inch straight pipe into the muffler and a quick 90 out the side. Now, if we were doing a symmetrical dual exhaust system, it'd be a no-brainer. But check it out. We have the fuel tanks. We physically can't do it. We got to snake around a bunch of other stuff. So obviously the driver's side, well, it's a whole other story.
Yeah, because we've got a couple of 90-degree bends to make. One to go from the driver's side converter down the crossmember, and another one to send the tubing down the frame rail to the rear of the truck to meet up with the muffler. Now, to do that, we're going to use this piece of equipment right here. Now, we know you guys probably don't have access to a tool like this, but if you send your car off to a muffler shop for a custom exhaust system installation, this is probably really similar to the piece of gear they're going to use. Now, by using the interchangeable dies, this machine's capable of bending tubing ranging from 1.75 inches all the way up to 3 inches. And by using a variety of fixtures, tools, and attachments, you can use the ram at the other end of the machine to do a traditional flared flange, a flat flange, or even a ball and socket type flange. Heck, you can even expand the piece of tubing you're working on for a slip fit connection, making doing custom exhaust work a piece of cake. Now, just like the hydraulic tubing bender we use for roll cages, well, this exhaust tubing bender is a piece of cake to operate. No giant manual levers here, it's all push-button control. Now, we know this non-mandrel bent 90-degree angle isn't the ultimate in flow, but for our 300 horsepower application, the 2.5-inch tubing will help get us by, and it should be plenty for stage 1 of this build. And when putting more than one bend in a piece of tubing, we need to make sure it stays on the same plane. That's as simple as using a level. Now, to make the down pipes that connect the exhaust manifolds to the catalytic converters, well, we're simply using a TIG wire as a template. And since our factory manifolds have a flared fitting, well, that's what we need to add to the down pipes. Then they'll bolt right up. Now, our driver's side exhaust tube with the S-bend actually turned out pretty nicely. And it kind of mimics the 2nd Gen Lightning's factory-style exhaust system. And I'm guessing these twin 4-inch mufflers are going to sound pretty nasty. Cool. Trim to fit later. Hey guys, welcome back to the shop. Well, we've had a chance to deal with almost all the problems related to our engine swap. Like we told you earlier, we had issues with the steering, brakes, oil filter location, the heater housing, and the exhaust. Now, for the brakes, well, we showed you earlier how we relocated the booster by sliding the bracket. We've now hooked up the master cylinder, the pedals are inside hanging where they need to be, and the coil cover, well, we had to grind it down for booster clearance. We made it look like new again with the help of some sandpaper and some Duplicolor semi-gloss black paint.
As far as the steering shaft goes, well, we know exactly what to do to connect it to the column. We just kind of ran out of time today. But the heater box, well, the Hyperfiber fix works great. We've got tons of clearance between the box and the cam cover, and now we have the ventilation that we need for defrost and for heat. The other thing you saw us do was to mount the engine part of the oil filter relocation kit that we got from Maximum Motorsports. Well, now with the cab down on the chassis, we've got the perfect spot for the filter mount. Check it out. We've got the filter tucked safely behind the front bumper for protection, up against the frame rail for further protection to where it's not going to come into contact with any road debris. But that's not all. Look at this.
Now, the downpipes from the manifolds were definitely a tight fit, but our converters are snugged up in the frame rails pretty nicely. Now, we'll have to do heat shields for things like brake lines and fuel lines, and we'll do that before we get the truck up and running. Now, so far, everything's just clamped in place because we don't know how loud these mufflers are going to be, and we may have to swap them around for the larger versions. Tailpipes kick out the side. Now, we've gotten quite a few engine swap details taken care of today, but there is one topic we've kind of been avoiding, and it's not everybody's favorite, but we've got a pretty slick solution for it. It's the wiring harness. We've also got a pretty clean solution for the non-return style fuel system. So the next time we have this truck in the shop, we're going to get those things taken care of. Hopefully turn the key and fire this bad boy up. Now, if you got any questions about any of the products we use on today's show, go to PowerBlockTV.com and check out the truck's website. Guys, thanks for watching Trucks. See you next week.
Hey, welcome to Trucks. Today, we're back on Project Rolling Thunder, which is our V8 converted Mazda B2500, which is nothing more than a reskinned Ford Ranger. So far, we've stuffed in the 4-valve Marauder engine and transmission and reinstalled our shortened drive shaft, following that with a custom-bent dual exhaust system that kicks out the side just like a full-size Ford Lightning. So that gets you guys up to speed on what we've already done to the truck and kind of brings us to an area that we've sort of been avoiding the whole time, which is the challenge of wiring and starting an EFI swap like this one. Well, we got some help today. Jeff Dunn from Dunn Right Performance is bringing something really cool to the table. And if you remember, we used Jeff's mass air conversion on our first-gen Lightning. A mass airflow system, like the GT Mustangs have been enjoying since 1989, is more efficient and infinitely more tunable. So we're going to use this mass airflow conversion kit from Dunn Right Performance that includes a new ECM or engine control module, an injector harness that plugs into the module and accepts the vehicle's injector harness, allowing you to control and monitor the rest of the vehicle systems. Oh, and by the way, in case some of you Chevy guys have already forgotten, it was the Ford that actually won the Muscle Truck Series. But even though EFI is nothing new, there's still a lot of guys, including myself, that just get a little intimidated with some of the voodoo involved in wiring an EFI engine swap. So what makes your system different?
It's interesting you use the word voodoo because you're right. A lot of people see wiring one of these engines as sort of a black magic, if you will. And while we may not necessarily be able to eliminate the mystery of one of these engines, we think that we've done a pretty good job to eliminate the complexity of wiring one of these engines.
Yeah, but you're telling me that, but I'm looking at hundreds of wires, multi-pin connectors, but yet you're telling me there's only 4 wires I need to be worried about connecting to make this thing run?
Just 4. You've got a battery positive, battery negative, we got a fuel pump, and a 12-volt key on.
Well, that's no more complicated than a carbureted engine.
Not with our kit.
Well, why don't you show us and everybody watching how simple this is to make this engine run?
Let's do it.
Cool. This system uses a factory-style multi-pin connector and plugs right into the existing engine harness. Don Barron, also from Dunn Right Performance, came down to help us fire off the Ranger. He's routing a power feed to the existing 4-cylinder fuel pump just so we have a fuel supply to start the engine. Now, this is kind of a demonstration on how simple the system is to hook up. So we're using this toggle switch as our key-on voltage source, connecting the basic connections to a battery standalone, and we'll be using a remote start later on to fire the engine off.
Now with our connections made, well, we still need a computer to make our 4-valve 4.6 run. So Jeff also provided us with a 99 Cobra production PCM with a chip installed that disables the passive anti-theft system. And they also hooked us up with an 80mm Pro-M mass airflow sensor and high-flow conical filter. Now, the Done Right system is designed to work with the more popular 99 to 04 4-valve Cobra engines. And while our Marauder 4-valve is largely similar, there are some subtle differences, with the intake facing the opposite direction, putting the throttle position sensor and a few other items on the wrong side. So to make the Marauder harness work with the Done Right system, well, they offer this adapter harness that plugs in between the two. Now, if we decide to go to a Cobra engine when we convert to Stage 2, we simply remove this adapter harness, plug everything back together, we'll be up and running.
Now, Jeff likes to tell us that with his Done Right performance system, we could get this engine to run in a shopping cart. Well, as you can see, we're about as close to a shopping cart as we could be with the engine sitting in the bare chassis. But like any other internal combustion engine, we got to have a fuel source. Now, our truck came with a returnless system with the fuel pressure regulated in the tank. Now, technically speaking, our truck came from the factory with a mechanical returnless system. Now, you Cobra guys, well, you know that you've got a returnless system, but it requires a fuel pump driver module to make the system work. Since we have the option from Done Right Performance, we decided to go return style just to simplify the system. So we had to change a few things around. Our temporary fuel supply line comes from the in-tank pump into a filter and then up to the fuel rail. The fuel comes back from the fuel rail into a temporary return line back into the tank, recirculating the fuel, creating a traditional return style system. Now, if you're keeping up with this, you're probably wondering how we're going to connect a fuel return line to a fuel rail that's designed to be returnless. Well, Jeff's got us covered with that, with a pretty cool solution that's going to save you time and money. Stick around. Hey, welcome back to Trucks, where we are moments away from firing off our 4.6 Mercury Marauder engine stuffed into our mini truck, Project Rolling Thunder, using Jeff Dunn's Done Right Performance harness system. But before we do that, we need to finish the conversion to a return-style fuel system.
So the first thing we want to do here is we're going to remove the original fuel rail pressure sensor. This is the sensor that feeds information to the original Marauder PCM so that it could determine proper voltage to the fuel pump for correct fuel rail pressure and injector pulse width. Now, our return line conversion starts with this adapter block. Just make sure the O-rings are lubed before installing. The fuel outlet gets a new gasket, and the fuel pressure regulator's O-rings also get lubed. Now, to get the fuel back to the tank, we're using a -6 90-degree fitting sealed with Teflon tape. And lastly, the vacuum reference hose is installed under the fuel pressure regulator.
Now, since we don't know the overall condition or how many miles are on the original Mercury Marauder spark plugs, we're going to go ahead and replace them with a fresh set of these E3 Diamond Fire plugs.
Now, it's pretty safe to assume that the stock fuel pump is not going to supply the demands of a big V8 engine. This was made for an inline 4-cylinder. So what we did was went to O'Reilly Auto Parts and got a Mercury Marauder fuel pump and just put it in line. We also clipped the return line so it wouldn't get internally regulated, but just flow freely into the tank. So now we know our fuel pump is going to match the demands of the engine because that's what it's made for. Speaking of fuel, we know the fuel in the tank is decent. We put it there and we drove around on it. But we don't know about the fuel in the fuel rails of that engine. It could have been sitting for years. So we're going to use some Start Your Engines, which is designed to stabilize fuel and bring vehicles out of storage. So it should do a good job on those injectors. Now, even without a filter relocation kit, it's a good idea to fill the filter up before you install it. But remember this, do not get any contamination into the fill hole. It's a direct connection to your engine and will get pumped directly into the oil passages and could damage your bearings. So we're reusing the Mercury Marauder inlet tube, but we've loaded it with the Pro-M air meter and filter that come with the kit. The rest of the connections are just as simple. They're one-way plugs that you can't make a mistake on.
All right, with that stuff taken care of, we're just about ready to fire this thing off. And like we showed you earlier, it only takes 4 wires to get it up and running. But you may notice we got a couple of extra wires here because we're going to need some more communication with the body once it's dropped down on the frame. Now, one of these wires is an AC compressor on signal, the other being a tach feed, capable of running a traditional analog tachometer. Now, this toggle switch is acting like our key on signal, with this being our start switch.
Check that. Yes, sir. That is awesome. Well, there it is, man. It's as easy as you said it was. 4 wires and we're up and running. Jeff, Don, thank you guys so much for your help. Wow, this is incredible.
Well, and if you decide you want to go with the supercharged Cobra motor, you're all set with that as well.
Cool deal. Well, you guys just get the truck back together and up and running. We're going to go check email, and we'll check in with you when you're done.
I'm going to stay here and listen to this thing run.
Today, we're hitting the streets with Project Rolling Thunder, our 4.6-liter powered Ford Ranger-based compact pickup to see just how our new drivetrain motivates this mini Lightning. It's all today here on Trucks.
Hey guys, welcome to Trucks. Well, today is kind of a special episode for me. This marks my 100th episode of Trucks TV. So it's only fitting we're working on an awesome project. This is Rolling Thunder, our V8 converted compact truck. It's a Mazda B2500, or started out that way, but we're calling it a Ranger too, since essentially it's the same vehicle. And obviously, there's been a ton of work done so far. So we're going to give you a little recap and catch you up on what's been done. After yanking the original 4-cylinder, the Marauder 4.6 and transmission went in without a whole lot of trouble. We rearranged some stuff under the hood, built a new exhaust system, and boy, it sounded great. Now, here's a couple of the things that you haven't seen us do. We actually bought a V8 Explorer radiator, but the core size was identical to the original 4-cylinder radiator, so we sent it back, saved some money, and we're repurposing this one. Now, obviously, we've lost the mechanical fan from the 4-cylinder with the 4.6, so we went to Summit Racing and purchased this 17-inch puller that should be pretty good and pretty efficient. On the radiator hoses, again, we went to the parts store and pieced some stuff together that is going to complete the cooling cycle. The upper hose is a stock one, so again, we save money there. And we're kind of betting that between the efficiency of the cooling fan, all the space we've got between the fan and the engine, as well as, believe it or not, there's still some pretty good room underneath the hood, despite this being a compact truck. So all told, this should be pretty efficient in the cooling department.
Now, based on the discoloration of the stainless steel exhaust tubing and catalytic converters, it's pretty apparent we've been running our 4.6 in the shop quite a bit. Now, before we run it anymore, and certainly before we drop the body back down on this thing, we got to do something to isolate the heat that the exhaust tubing and cats make from any non-metal object, like the wiring harness, sensors and switches on the transmission, as well as the transmission shifter cable. Now, catalytic converters can operate in a heat range of 1,200 to 1,600 degrees. That's why the OEMs take so much care to insulate the areas around them. And with ours sitting right next to the transmission and the transmission cooler lines, well, we don't want to heat up the transmission fluid any more than we have to. So to get that done, we're going to use a combination of simple aluminum heat shields and some exhaust heat insulation products. Now, installing the exhaust wrap is pretty straightforward, but you are going to need some stainless steel zip ties or retaining straps to hold it in place. Now, to hold the heat shields in place, just using a couple of self-tapping screws. Now, the thermal protective wrap we put over the exhaust tubing and secured with stainless steel zip ties came from Taylor. And they also make this thermal protective sleeve that's good for up to 1,200 degrees Fahrenheit. So we're going to put a section of this over top of our plastic-coated B&M shift cable. The last thing we need is that outer plastic layer melting. Now, we know our shifter cable was built to withstand some heat, but our 4.6 is going to make plenty of it. So we're installing this just to be on the safe side. All right, with our heat issue resolved, we can move on to one of the last pieces of our little stage 1 puzzle here, and that's getting the automatic transmission operational. And when this engine and transmission combo sat down in between the frame rails of the 03 Marauder that it came out of, well, they were both electronically controlled by the same computer, the PCM, or Powertrain Control Module. And since we've got our dual overhead cam 4.6 running on a standalone engine management system, we need to do something similar for the transmission as well, since it's also electronically controlled. So we picked up a standalone harness and a standalone computer for it as well. Now, the wiring harness plugs directly into a few key sensors on the side of the transmission. Now, it also allows you to wire in a neutral safety switch right into your start circuit. Now, the other end of the harness, one piece plugs right into the computer, and you've got a handful of other connections to make for throttle position sensor, RPM input, a couple of power and ground hookups, along with a couple of other connections. And with the Bominator transmission control system, you can even set your truck up to have 2 separate transmission files or calibrations. Say you want to set it up to have normal, everyday street driving characteristics, and you want to be able to flip a switch and go to a more aggressive shift pattern to match your more aggressive driving, well, you can do that. Or say you got a street strip vehicle that's maybe spraying nitrous, and you want to be able to load a more aggressive or race type transmission calibration when you activate the nitrous, well, you can set it up for that as well. Or you can do like we're going to do, keep it really simple and run a single tune. But there are a couple of changes we need to make to the software before we load it up. Now, the Bominator software comes preloaded with a few different calibrations. We've chosen a 4-valve Cobra file because it'll pretty closely match what we want out of our Ranger. The problem is the Cobra has about a 500 RPM red line advantage over our Marauder engine. So we're just going to go in here, lower the shift points across the board so they're just underneath our 6100 RPM red line. Save our progress, we can upload this file into our computer. But it's so easy, even I can do it. All right, once we get this wiring harness installed, power and ground hooked up, and everything plugged in and connected to the computer, we can upload the file from the laptop. We should be up and running. Now, installation is really straightforward, with the harness utilizing factory-style connectors plugging right into the forward sensors on the transmission. Now, it would be nice if we could remove the transmission portion from the rest of the wiring harness, but we've got things like the O2 sensor hookups that are tied into it. I guess we could cut the loom open and separate the wires we need from the ones we don't. But it's just not worth the hassle. Like we've told you plenty of times before, this automatic transmission's going away when we go to stage 2. So what we're going to do is bundle up and tie off the connectors we're not using. We can finish installing the standalone harness. We'll be in good shape.
Up next, it's go time for Project Rolling Thunder. And later, it's bigger caliber go-fast goodies for Rolling Thunder. Stay tuned.
Hey, welcome back to Trucks. Well, Project Rolling Thunder is all bolted back together and up and running. We're ready to put some test miles on this thing.
From the first moment we hit the road, Rolling Thunder sounded and felt really strong. And as fun as it was driving the ultimate sleeper, the stock suspension kind of started to show us some problems that we already knew we had. But horsepower wasn't one of them, unlike when we first got the truck. Now there's all this truck can handle, and then some.
And after putting a few miles on the truck, we noticed a less than healthy noise coming from under the hood.
Yeah, that rattle, you can hear it more at very light throttle, almost just off idle, than you can under load.
Heard it then.
Yeah. I think our screaming deal engine wasn't so much of a screaming deal.
Yeah.
Now, we knew we had a slightly wounded engine, but it was really tough to resist the temptation of our newfound 300 horsepower. and just cruising around, we didn't have any engine noise whatsoever. And the gauges look great. Heck, even our stock 4-cylinder radiator kept our V8 nice and cool all day long, never getting above 200 degrees with the help of the electric fan.
But the engine noise was still there, and we knew we were pushing our luck. So we reluctantly headed back to the shop. Yeah. Wow, that is definitely what we're hearing inside the cab. And if I was a betting man, I'd say that's a connecting rod getting ready to let go. But you know, that's okay because we got a screaming deal on this engine. The guy that sold it to us was a salvage yard, and he even said it was from a theft recovery vehicle. So even if we did have to spend the coin to rebuild this, we'd still be all right at it. But you know, the real reason to stick this engine in here was to make sure that it fit and get this truck ready for the next step.
Yeah, and with that accomplished and the engine a little bit injured, well, I guess we have no choice but to move right into stage 2, which we've been anxious to do anyway, so no big deal. Now, we definitely got some drivetrain upgrades we're going to make, along with some unique suspension modifications that are a little bit outside of the box. Now, as far as the original Marauder engine's concerned, well, we'll yank it out, set it off in the corner, and let it collect dust, or maybe ship it off to Horsepower, see what they can do with it. Either way, we've got some serious hardware to replace that thing. And at least we got to put a few miles on this truck. Let's get it inside.
Man, it looks good under there, doesn't it?
Yeah, I hope the new one fits too. Hey guys, welcome back to the shop. Well, since the beginning of this project, we've been chomping at the bit to get right to stage 2. And, well, there's no better time than right now.
But before we started tearing this truck apart, again, we wanted to throw it on the scales and see what our weight bias was, front to rear, as well as how much weight we've actually added by swapping to a V8.
And it looks like we've got some pretty good news as far as overall weight and weight bias is concerned, especially considering that our V8 and automatic combination weighed 200 pounds more than the anemic 4-cylinder 5-speed combo that came in our little Mazda Ranger. Now, originally, our truck weighed in at 3,090 pounds, but the scales show us we're now weighing in at 3,125, meaning we only picked up 35 pounds overall. And even better yet, well, our weight bias is still at 62%. And that tells us all the effort we put into setting the engine back as far as possible, doing a slight relief to the firewall, and all the other little things we did to either remove weight altogether or locate that weight farther to the back of the truck has paid off. And it's got us on the right track to getting closer to that ideal 50-50 weight split front to rear for stage 2 of this build.
Now, you heard Ryan right. We've switched to a V8, a 200-pound heavier V8, but our vehicle weight is still almost the same. Where'd that 165 pounds go? Check this out. The rubber mat, liners, exhaust system, the condenser, the AC system, all of this stuff seriously contributes to a lot of weight loss. And we haven't even gotten serious about weight reduction yet. But there's another great way that we can reduce weight and increase efficiency, and that is by switching from an automatic transmission to a manual.
Yeah, because with the convenience of an automatic comes a weight penalty. Not to mention, they're just not as efficient at transferring power as a manual gearbox. That's why we're going with this Tremec Magnum T56. Now, this is a new 6-speed transmission from Tremec, and there's lots of cool stuff to talk about, but we'll get to the details later. For now, I will tell you, this thing will handle 700 foot-pounds of torque, which makes it a perfect match for our engine. Now, to connect it to the engine, we're using this lightweight steel SFI certified bell housing from QuickTime. Now, due to its compact design, it maximizes header and transmission tunnel clearance. Now, a lot of guys just reach for an aluminum bell housing, but we're going to be making a lot of power. We're not going to be easy on the truck. So to play it safe, we went this route. Speaking of lots of power, check this out. Now, just like our Marauder engine, this bad boy is a 4.6-liter dual overhead cam V8 out of the Ford racing catalog. You guys might know it better as the Illuminator. Now, it's based off of the legendary and nearly bulletproof 03 and 04 Mustang Cobra Terminator engines that were capable of producing and withstanding gobs and gobs of power. Now, one of the things that makes this one different and where it got its name is this one has an aluminum block, saving us some weight. Now, the Illuminator comes in 2 different versions, a high and low compression, either 10-to-1 or 8.5-to-1. We went with the low compression because we're going to be running forced induction and lots of it. Now, one of the best parts about this engine, it's got brand new rod bearings.
Now, you Cobra guys know that the stock Terminators came with the Eaton M112 root-style supercharger. Not a bad piece of gear. But this is an awesome upgrade. This is the Whipple Ford Racing 2.3 root-style supercharger. Now, just bolting this on a stock Terminator is going to get you an additional 85 horsepower at the wheels. And one of the cool things about the Whipple is that the front pulley is interchangeable. With this 3.5-inch pulley, it's going to get us somewhere around 13 pounds of boost. But the good thing is, if you want to make more boost, it's as simple as reducing the pulley size. Now, this combination on Von Gitten's drift car netted him about 680 horsepower and 600 foot-pounds of torque at the rear wheels. Now, do we need that with a 3,000-pound Ford Ranger? I don't think so. But it's sure fun to know that we can get there pretty easy.
Hey guys, welcome back to the shop. Well, we're back on Project Rolling Thunder, making preparations to move on to stage 2 of this build. Now, it's going to be a pretty drastic transformation from both the stock Mazda B2500 version and stage 1 of this project. With this swapped-in engine clattering and making not-so-healthy noises, it was time to go. And Kevin and I have both been anxious to ditch the slush box automatic in favor of a manual transmission. Now, the engine we're going to be installing in place of the wounded Mercury Marauder 4.6 is going to be a little bit heavier due to the blower and intercooler and supporting hardware. So to counter that, we're going to be installing a fuel tank at the very back of the frame instead of the mid-frame mounted stock plastic tank. So we just sent some dimensions to the guys at Rick's Hot Rod Shop, and they crafted up this super slick stainless steel tank. Now we're going to drop it right in between the frame rails and behind the rear axle. And that'll help us with the weight bias. But before we do that, we got to figure out the rear suspension.
Now, we wanted to do a little bit better than just some lowering blocks or shackles and really enhance the handling capabilities of this project. And there's lots of aftermarket options out there. There's 4-links, there's Watts links, there's all kinds of torque arm systems that are really well engineered. But we wanted to go independent rear suspension. Now, since we're completely redesigning the front suspension and doing a custom one-off setup, we wanted to go with more of a subframe system for the rear. And we found a killer option. This is an IRS from a Cobra Mustang. Ford introduced these in the Cobras in '99, but this one is from an '04 with the beefed-up 31 spline half shafts, limited slip differential, and 373 gears. Now, there's good and bad points about this IRS system. The good point is that it's designed to handle the power output of a supercharged engine application, which is precisely what we're going to be throwing at it. Bad points? Well, there's a wheel hop issue. You Cobra guys know this. And it's due to the rubber isolators and the various design aspects of the IRS. Now, because of that, a lot of straight line guys ditched this entire system in exchange for a stick axle, which also makes this inexpensive and available. Not to mention, there's aftermarket support to compensate for the factory shortcomings. So the bottom line is this is an adjustable, strong, independent suspension system that is going to up the ante and really turn our little truck into a corner carver.
Now, another reason this stock fuel tank has got to go away is that it's going to try to occupy the same space as that IRS subframe assembly Kevin just showed you. And needless to say, the 7.5-inch rear axle has got to go as well. And I'm kind of surprised that this thing held together under V8 power during the test drive. But I guess the fact that the engine was a little bit wounded and these bike tires weren't exactly hooking up helped the axle live. Now, we're stripping the front suspension down just for the sake of getting it to a bare frame. That way we can set the frame at ride height and work the front and rear suspensions separately. Now, there aren't any off-the-shelf bolt-in kits whose primary focus is to get the truck to handle better. They're mainly designed to sit the truck lower down for looks and aesthetics. But I guess that's to be expected since nobody really takes a pickup truck to a road course. So we're going to be on our own for a completely custom front suspension that handles. Hey guys, welcome back to the shop. Well, we've got the frame of Project Rolling Thunder just about completely stripped down in preparation for some pretty serious suspension modifications. But before we cut off the first bracket or even make the first weld, we wanted to point something out. Check this out. With the front of the frame on jack stands on both sides, we've got a good 2 or 3 inches of flex underneath this left rear corner. So we're definitely going to have to address the torsional rigidity issue. And all that movement is without any weight in the chassis, which is only going to amplify the problem. Now, to remedy it, we've got a couple of things we're going to do. We're going to add some bracing, and we're going to weld some of these cross members that are currently just riveted in place, like this one that's holding the front and rear frame sections together by way of the leaf spring hanger, which is going to go away. So it'll get all welded together, and that'll help stiffen things up. But the biggest thing we can do to increase the overall chassis stiffness is to install a well-thought-out roll cage. Now, it's hard to tune a suspension or even calculate spring rates when the frame itself is acting like a spring. But before we break out any tools, we want to drop the body down on the frame, select our ride height.
Well, check out the new mocked-up stance of Rolling Thunder, and it is amazing how much difference lowering a vehicle and throwing a set of wheels and tires on can do for the appearance. But as good as this thing looks, appearance is not our main goal. We want to make this truck handle. Now, the wheels and tires are something that we borrowed from a horsepower project out in the warehouse, but they're similar in style and size to what we're eventually going to be putting on this truck. Check this out as well. See the negative camber we've dialed into the mock-up of the wheels and where they sit. It's going to give us the ability to really make this truck handle, having adjustability on all 4 corners. Not to mention the fact that some negative camber on the back end of a pickup truck, well, it's not something you see every day.
And take a closer look at the front wheel well. We've marked the fender and dropped a plumb line where the original front axle center line was. And we've shifted the wheel forward 1.5 inches because that's where the new front axle center line is going to be, lengthening the wheelbase. And that's going to have the same effect as moving the heavy engine and transmission rearward in the chassis, helping with that weight distribution we've been stressing so much. And only because it's going to make this truck handle the twisties. And with this giant wheel well, if we hadn't have told you, well, you probably wouldn't have noticed. Now, one of the things that's going to help us move some of the weight to the back of our pickup truck is by relocating the battery. Rusty's off-road battery box is laser cut from 1/8-inch stainless steel, meaning you never have to worry about corrosion issues, making it great even for marine applications. It's got 8 mounting holes on the bottom, and only 2 bolts hold the lid in place, making it really convenient. And it'll hold any Optima battery out there. And for a show car look, all you got to do is polish the stainless. Now, if you got any questions about anything you've seen on today's show, check out the website. Guys, thanks for watching Trucks. See you next week.
Today, we're installing a Mustang Cobra independent rear suspension in our Ranger-based pickup, Project Rolling Thunder. Then, we're picking pads and rotors for the street and for the track. It's all today here on Trucks.
And more aggressive yellow stuff pads.
Hey guys, welcome to Trucks. Today, we're back on Project Rolling Thunder, which is our attempt to turn an 01 Mazda B2500 4-cylinder plain Jane pickup truck into a powerful forced induction V8 manual 6-speed transmission street and track machine. Now, we're obviously getting away from the budget a little bit because that was stage 1 of this project. And we're going to spend a little bit more coin this time around. We're going to try to do it wisely.
Now, part of that sinister plan is to take tried and proven high-performance racing parts and fundamental techniques and apply them to this chassis, such as the independent rear suspension that we borrowed from the 04 Cobra. Now, another place that we drew some inspiration is from another track-prepped V8 Ford Ranger that was featured on POWERBLOCK not too long ago. This 95 Ranger belongs to Matt Beauchard of Beauchard Racing and Fabrication, and it's a little bit of inspiration for us in our project. The functional splitter and full-on roll cage make this a 100% race truck, powered by a 302 carbureted V8. Custom front and rear suspension of Matt's own design make this truck handle like crazy.
Now, just like you guys, we don't have a frame jig or a frame table to work off of, so we're going to use a flat and level section of our concrete shop floor to get the job done. Now, the last time we had our truck in the shop, we took the body, set it down on the bare frame, and selected our ride height. And we just welded on these stands, which is nothing more than a piece of tubing, a nut and a washer welded to it, and then a bolt on the bottom so it's threaded and height adjustable. That way we can level out the frame and make sure everything's right. Now, the first step in installing our IRS subframe is going to be to remove all the shock mounts, leaf spring hangers, and brackets that are going to be in the way. That way we've got some clean and flat real estate to work off of. Now, our favorite way of removing the stubborn factory frame rivets is to cut an X in the head and use a sharp chisel on our air hammer. Makes quick work of it. All right, we've got the rear spring hangers and shock mounts knocked loose from the frame. But before we remove this front spring hanger, we want to make sure this is tack welded together and nice and solid. If you take a closer look, you can see this front frame half and rear frame half overlap and are attached at this point by this cross member and about 6 or 7 rivets. 4 of them holding this hanger in place. So just to be extra cautious and make sure nothing moves around, we're going to weld this up and make it solid.
And we wanted to compare the weight of our Cobra IRS suspension system with the stick axle and springs that we took out of the Ranger, just to show you the difference. Now, our Cobra system, minus brakes, weighs in right at 309 pounds. In order to get an accurate representation of what this thing weighed, with brakes, springs, all that kind of stuff, well, we're just going to actually stick it on the scale. We've got a spring, another spring, caliper, rotors, and don't forget the pads. That brings us to, wow, 367 pounds total weight.
Now, the stock Ford 7.5-inch rear axle with brakes, leaf springs, and shackles weighed in at about 260 pounds, meaning we picked up a solid 100 pounds. And why are we excited about that when we all know adding weight to a high-performance vehicle is kind of counterintuitive? Well, that's because we're adding it in the right spot. If you guys remember, the stock version of our truck, as well as Stage 1, had a 62 to 38 front-to-rear weight bias. Not good for putting power through the rear wheels. So by adding 100 pounds to the back, we're going to help with that weight bias. We're going to lower our overall center of gravity.
Now, with the entire independent rear suspension completely disassembled, Ryan's going to grab the subframe and get started on the installation. Now, the biggest mechanical advantage to an independent rear suspension is that when one wheel moves, it doesn't affect the other wheel. Unlike with a stick axle, when one wheel travels up, the other one has no choice but to react and to move kind of along with that. So an IRS has a handling advantage right off the bat, but it gets better because it's tunable. And just like a front suspension, there's an upper and lower control arm, with the upper having an adjustable eccentric, which allows you to change the camber setting or the tilt-in of the wheel and tire at the top. Now, another tuning point on this system is the adjustable tie rod, which gives you a toe-in adjustment and helps you really control the way a vehicle tracks with this system on it. Now, the Cobra systems like this have a slightly larger sway bar than the GT, along with the beefier 31-spline CV half shafts and, of course, the giant lower control arm that's cast aluminum. Now, as good as this system is, the aftermarket allows us to make it even better. Now, I've left this side completely assembled to show you where we can improve it. Now, the spindle, or upright, has a spherical style upper and lower ball joint, and they're not worn out and fairly precise, so they're going to stay. But the upper and lower control arm bushings, well, they're made out of rubber, and although they offer a nice, smooth, and vibration-free ride, they're mushy, and they contribute to wheel hop, so they're going away. Now, this guy, as well as being a giant weight, is a vibration dampener that was put there by the Ford NVH engineers to help control noise, vibration, and harshness. Well, quite frankly, we're just not as concerned about that as we are about controlling the wheel hop issue and improving the handling. So this guy goes away, as well as these rubber isolators that connect this dampener to the third member and lock it into the chassis. Well, they're going away too. So when we come back, we're going to show you exactly how we're going to improve on a system that was already really good from the start.
Welcome back to Trucks, where today we're installing an 03 Mustang Cobra independent rear suspension system underneath the back of our 01 Mazda B2500 Ranger-based truck, all in an attempt to make this pickup handle more like a car. Now, once we get the subframe located and positioned where it needs to be, we can weld on some brackets to attach the subframe. But like Kevin told you earlier, we've got to address the factory compromises and shortcomings of this setup, and with the help of the aftermarket, we can make this system even better.
Now, if you remember, we used a Maximum Motorsports oil filter relocation kit in our Marauder engine in Stage 1, but their strength really lies in Mustang Performance suspension system upgrades. So, since this is a Cobra IRS, well, we had them send us a kit to help beef it up. This is their Grip Pack IRS upgrade and replaces the factory rubber bushings sleeved in steel with these Delrin bushings, very hard compound with a hard anodized aluminum center pin for strength and lightweight. They also send enough shims to get a very precise realignment when you install the new system. Lubricating grease, a scuffing pad to clean out any debris or corrosion from the control arms without distortion, even a pair of gloves to keep this nasty stuff off your hands. But the best thing about the kit is that they send an installation and removal tool with the kit. It makes it pretty easy. Now, the control arm bushings are different sizes, so match up your removal tool to the bushing with a test fit, and follow that by the spacer, washer, and nut, and snug it up by hand. Then, using hand tools, slowly tighten the nut and the assembly. It's important not to use pneumatic tools so you don't force any distortion into the aluminum control arm. Now, it may take a while, but you're going to know when the bushing comes out. Now, aluminum control arms are lightweight, but aluminum is soft. That's why they provide a scuffing pad, so you get rid of the schmutz and the corrosion, and you don't distort the aluminum. It's very important that you have a nice, flush fit with the new Delrin bushings. Now, don't confuse Delrin with urethane. It's a much higher durometer and does not compress. Delrin was actually invented in the 50s by DuPont and is used as a bearing in Hot Wheels. Pretty cool. Now, this is going to work great for us for a test fit. And by the way, don't forget some anti-seize on the bolt threads and in between the washers to make sure everything doesn't bind. Now, the shims and the lube, that happens on final assembly. The shims really are only there to take up any slack that may have been created by eliminating the rubber bushing. So for now, this is going to serve us very well, and I've got a few more of these things to do.
All right, with the subframe blown apart and the frame ground down to bare metal in a couple of spots, well, we can finally get to the installation of this thing. Now, we knew where to locate it and how to position it based off of measurements that we took and from information we gathered from the helpful and knowledgeable tech guys at Maximum. Now, before we disassembled the stock truck, we measured where the rear axle centerline was of the leaf-sprung solid axle pickup, and that's right here. Then we also determined the axle centerline of the independent rear suspension system and matched things up. Now, the first thing we're going to do is install and weld in some temporary bracing to lock the subframe in place. Then we can get to work making up and fabricating some mounts to permanently mount the subframe. But it's still going to be bolt-in and it's still going to be removable. Now, after measuring and measuring again and triple checking and measuring again, we determined we had the subframe sitting at the exact ride height and location that we needed. So we just locked it in place using some 1-inch angle iron. And these will serve as temporary braces until we can design and cut out some permanent brackets using our Torchmate. Hey guys, welcome back to the shop. While Kevin was working on the control arm bushings, I had a chance to make up a crossmember and some brackets so we could locate our subframe. Now, like we told you earlier, this thing's gotta be removable, so it took a little extra time to make brackets that would bolt into the frame. But it's gonna be time well spent if we've ever gotta work on any of these suspension parts that require a little extra clearance. So let me show you what I've done. Now, the first thing I did was plasma cut a couple of holes in the backside of the tubular subframe, and that will allow us to install this plate with two 1/2-inch grade 8 captured nuts welded to the backside of it. Once that's welded solid, we can install our Crossmember, which is a piece of 1 3/4 DOM tubing that we bent up on our hydraulic tubing bender, along with some 3/16 plate we cut out using our Torchmate. And once everything's welded solid, we can install the Crossmember on the inside of the frame rails and weld it up for good. Now, if you notice the location of the Crossmember mounting points, well, they're right here above the lower control arm pickup points. And that's because that's where a lot of the suspension energy and load is going to be transferred. So doing it right here will eliminate any subframe deflection, often found in the factory IRS setup. The front half we did a little bit differently. This is a piece of 1.5 DOM welded directly to the subframe and then again to the bottom side of this bracket. And that'll handle any vertical loads. Any side-to-side movement will be handled by this piece of 1-inch 3/16 Walt DOM, again welded to the same bracket. We've got a couple of captured nuts welded to the inside of the frame rail, a gusset for strength, and this thing is removable and still plenty strong. But we're not done yet. Now, just to make sure this subframe is installed as rigidly as possible, I went ahead and added another piece of plate in between the upper control arm mounting points. This top piece will become the bracket that's welded to the frame rail. But before we do that, we've got to notch the frame for upper control arm clearance. Once we do that, we'll box in the remaining section of the frame rail and add the necessary gussets. Now, the benefits of having these brackets at the frame or even inboard of the frame is that it allows us to remove the goofy, flex-prone factory subframe end. Now, this thing was designed to fit an existing Mustang platform, and now that we don't need it, we get to cut them off. Now, the things that limit running really wide tires and wheels on the back of a Mustang are both the shock and the forward subframe mounting point. So by eliminating these, we give ourselves more options for fat rubber.
Now, I wanted to show you what the rest of the components in the Maximum Motorsports grip pack look like, as well as what a little bit of elbow grease and paint can do for the appearance of this stuff. Now, these stock sway bar end links are going away to be replaced by the Maximum links, which are billet aluminum and hind jointed for adjustability of sway bar preload. The stock CV half shafts, well, there's nothing wrong with them, but we media blasted them and threw a coat of paint on. They're good to go. The upper control arms have the Delrin bushings set into place. We also media blasted and threw a coat of paint on them. They look pretty good. Now, the lowers, we blasted them as well, but we didn't paint them. Instead of painting, we put a barrier coat called shark hide that's supposed to keep it from oxidizing and keep the appearance of aluminum pieces and other raw metals looking good. We're going to test it out and see how it works. Now, the 8.8 pumpkin just got cleaned up, but the rear isolator, which is rubber, gets replaced by a solid billet aluminum piece, just as the front left and right isolators are replaced by, again, solid but adjustable billet pieces. Now, the last pieces of this puzzle are the stock tie rod ends, which get replaced by these lightweight, hard anodized billet aluminum rods, again, with hind joint ends that are bump steer adjustable. Now, all of these pieces will virtually eliminate any wheel hop issues that we may have had with the stock system, and look pretty snazzy doing it.
Hey guys, welcome back to Trucks, where our independent rear suspension install is just about complete, short of a couple of gussets for the upper mounts. Now, everything's assembled and loosely bolted together, and everything fits just like it's supposed to. And it looks pretty good too. But let's take a closer look at what we did for upper A-arm clearance and what we did to finish off the upper subframe mounts. Now, once we were happy with the amount of frame we trimmed for A-arm clearance, we went ahead and plated the bottom of the rail and boxed in the remainder. Then we just added these vertical gussets for our upper subframe mounts. Then, to finish things off, we added this top plate for strength and to help out in the looks department. And we'll obviously box in the frame rails from this point forward. Now, if you're doing a project, anything similar to this at home, and you're worried about compromising on strength, well, there's no need to. Think about this. The factory IRS subframe assembly was held in place with just 4 bolts. Here, we've got 12 of them. So those 12 bolts, along with the cross members, brackets, and bracing that we've added, I'm sure we've significantly increased the stiffness of the subframe itself and this entire frame section, which is a good thing, because this truck is going to get hammered on.
Now, it doesn't make any sense to do all these chassis upgrades along with a supercharged high horsepower engine and not pay attention to the brakes, because trust me, we want this thing to stop. So out back, we're using EBC's dimpled and vented Cobra rotors. Now, we're using a bit of strategy here because we've picked up an extra set of rotors, and they're red stuff and more aggressive yellow stuff pads. So once we bed in the pads to a specific rotor, well, they become a match set, so we can easily switch depending on where we're driving from a street to a track setup.
Today, we're installing our supercharged Cobra Illuminator engine and 6-speed transmission in Rolling Thunder. And we're boxing the frame while adding speed holes. Then we'll come up with a plan for adding the front suspension and the fuel tank. It's all today here on Trucks.
Hey guys, welcome to Trucks. Well, today we're going to be assembling the drivetrain of Project Rolling Thunder, and hopefully for the last time. And that means installing our new flywheel and clutch, setting up our hydraulic throwout bearing, and hanging the 6-speed off the back of our blown 4.6 here. And by the end of the day, we're going to drop the whole thing down in between the frame rails.
And hopefully, by the time Ryan has got the engine and transmission assembly ready to drop down in between these frame rails, we've got these boxing plates at least ready to tack in. Although, right here where our IRS is mounted in, it's going to be pretty stiff. But the rest of it, like we showed you before, very flexy. Although Ford did a nice job of boxing up until here, there's this vast expanse in the middle that we've got to do something about. Now, these Simpson speed holes aren't just for appearance. Check this out. This is substantial. That's a lot of weight that we're dropping and not sacrificing any rigidity. Plus, it allows us access in between the rails to run fuel lines, electrical harnesses, things like that. And it's going to look pretty darn cool doing it.
Now, for our application, we knew we were going to need a better than stock replacement clutch. So we went to Summit Racing and picked up some parts from Centerforce. Now, the disc itself is a dual friction unit with a segmented carbon composite lining that'll keep heat down while increasing torque capacity. And the pressure plate features aircraft-grade billet aluminum and a heat-treated and replaceable friction surface. It also features their patented ball bearing activated diaphragm and standard Centerforce centrifugal weight system. That'll increase clamping load as RPM increases while still maintaining reasonable pedal pressure. Now, the aluminum flywheel we picked up is from Centerforce as well. It's got a mechanically retained starter ring, and just like the pressure plate, it's SFI certified and has the heat-treated and replaceable friction surface. Now, these parts are designed for specific road racing applications along with drag racing. And while they do cost a little bit more, well, they definitely have benefits. The engine's going to rev faster, it's easier to match revs while shifting, and the engine's just going to plain old accelerate faster due to the lower inertia. Now, we also picked up a billet steel flywheel for comparison's sake because we wanted to show you the weight difference. Check this out. Now, the steel flywheel weighs in at nearly 30 pounds. Looks like 28 to be exact. While the aluminum version looks like, well, it's less than 13 pounds. Now, to engage and disengage our new clutch, we picked up a hydraulic throwout bearing from American Powertrain. It features a threaded and adjustable sleeve with O-rings that seal to the transmission input shaft, along with an additional spacer so you can get this to work with a variety of transmission and clutch setups. Now, it's also got two braided stainless lines, one with a bleeder on it and the other that we're going to try to adapt to our factory Mazda clutch master cylinder. But before we install it, we've got some measurements to take. The first thing we're doing is installing the bearing assembly and making sure it's sitting flush. Then we can take our first measurement from the bell housing mating surface to the front of the throwout bearing. But before we can get our second measurement, there's some installation work we've got to do, like getting this pilot bearing installed in the back of the crankshaft. We're using an impact socket and a mallet. Next was the bell housing separator plate. We followed that with the aluminum flywheel. And since this thing's going on for good, we use some red Loctite on the bolts to make sure it stays put. And after starting the bolts by hand, we're just snugging them down using the impact wrench. We follow that with an accurate torque. And by using an alignment tool, we can finish up the job getting the clutch disc and the new pressure plate installed. Now, the first step in tightening down our pressure plate bolts was to torque them to 33 foot-pounds. But these are torque to yield factory bolts, so we need to go an additional 60 degrees. But what if you don't have a torque angle gauge? Well, you can do like we're going to do and just use a template. Now, you can use a piece of cardboard or whatever you got laying around, but we had this old steering wheel kicking around and we're going to use it. Basically, we just marked off 60 degrees on the outside edge of the wheel. We'll line our ratchet handle up with the first hash mark and tighten till we hit the second mark. That way we know we've gone 60 degrees and it's done right. Now, once you get started in this process, you need to make sure that the crankshaft and the flywheel don't move. If it moves on you while you're turning the ratchet, you'll lose track of where you are and have to start all over again. Now, to make sure it stays put, Kevin's using a flywheel holding tool we picked up from Matco. And with the bell housing installed, we can get that second measurement we needed. And it goes from the bell housing to transmission mating surface to the very top point of the clutch fingers. And using these measurements and doing a little bit of math, we were able to properly set the height of the adjusting sleeve on the throwout bearing. It needs to have an 1/8 inch clearance in between the face of the throwout bearing and the clutch fingers to operate properly. Now, for our application, we ended up using the provided spacer sleeve. Now, the 2 O-rings on the throwout bearing are a snug fit, so if you need to, lubricate them with brake fluid only. One final measurement will verify we're still right on the money. That's it. Cool. And last but not least, we can install the bell housing, hopefully for the last time.
Up next, the magic of speed holes and why they work. And later, making mods to make it all fit. Stay tuned.
Hey, welcome back to Trucks. Well, Project Rolling Thunder is going to be one seriously fast little street truck with a rock-solid foundation that handles like a slot car. Part of creating that foundation involves boxing the frame all the way back. Now, boxing a chassis in is nothing new. There's really nothing new under the sun. This has been done for years, and it's quite a simple process. It involves using cardboard for templating, tracing out your design, transferring it to metal, and then trimming it out and welding it in place. It's pretty simple and can be done with basic tools, so this is a project you guys can do at home. Now, we're going to box all the way back, leave a little bit of room for suspension travel, and go all the way out the back. And since our new fuel cell is going to sit right here where the spare tire carrier now sits, obviously this boat anchor's got to go away before we can box these rails in. Now, weight transfer rearward is one of our main overall goals for this project. So we're going to have to buy back some of the weight that we're losing by removing this spare tire well. But the stainless steel fuel cell that we're installing in its place will more than compensate, especially when it's full. Now, cutting off the factory rivets is kind of fun, and it satisfies some weird primal urge. It's kind of like therapy. Now, with the big chunk out of the way, we can start making our template. Now, it doesn't really matter what you use as long as you can manipulate it and trim it and transfer it onto metal. I'm using some cardboard, but a lot of people use a lighter gauge. I just like this because I can move it around and it's a little more substantial. So basically what you want to do, put it up against your workpiece and trace around it. Now, the good thing about a frame is that the rails are usually symmetrical, so you can make one template and just use it for both sides. Now, templating is a simple process of tracing and trimming. And you want to start off cutting a little bit more than the outside edges of your project, and then dialing it back in, which is much easier to do on cardboard than it is steel. A little more forgiving, too, if you make a mistake. Now, the second most used tool in the whole shop is a black marker, and it's used to trace the pattern onto the 1/8 inch plate steel. Now, we're using our Torchmate CNC plasma table to cut the speed holes. We just found something round and the right size laying around in the shop to use as a template. So all of our boxing plates are cut out and trimmed, and the speed holes are cut out, and we're ready to tack these things in place. Wanted to show you something first. This is not just for aesthetics, although they do look cool. Check this out. These are the cutouts for about half of the boxing plates for one frame rail. And it's weighing in at 8 pounds. So you got 16 pounds worth of weight just from cutting the speed holes without sacrificing strength. If that doesn't sound like much, think about this. Got the rear bumper, the spare tire well, all the different brackets that we're pulling off. The point is, all of this matters. We get the strength that we want, and we get the weight reduction that we want, because every little bit helps. Well, the frame's a little rusty, but nothing a couple passes with the grinding wheel won't fix. Then we're ready to tack our plates in. Now we're tacking all of the plates in individually, just in case we have some fine tuning or trimming to do. A tack's a heck of a lot easier to cut out than a fully burned in weld. Now the factory formed rails are not square or symmetrical, so you may have to do some forming. With everything looking good, you can make some fire.
Hey guys, welcome back to the shop. Well, we've got most of our boxing plates welded in place, and we're grinding down those welds for a little bit more finished look. Now we've got some more plates to make and some more welding to do on both the cross members and the bottom side of the frame rails. But we're going to take a break from this for a second because we want to drop our new engine and transmission down in between the frame rails and see where our transmission mount lines up.
Now, the good news is we know the engine's going to fit, because essentially it's exactly the same engine block, and we're using the same isolators or engine mounts that we used on stage 1 with the Mercury Marauder engine. The problem here is that these are factory and they're rubber, and the aftermarket doesn't really support a Mercury Marauder mount. They have Cobra mounts, so we're going to have to switch to a Cobra mount later on. We'll cross that bridge when we come to it. The important thing is knowing where this transmission mount's going to go and what we're going to have to fabricate to make this work. The other variable are these long tube headers. Mike and Joe over at Horsepower had these Flowtech long tubes kicking around, so we just thought we'd throw them on, see if they fit down between the rails, or if we're going to be locked into the factory Cobra cast iron manifolds that we know work.
And to make sure the transmission ends up in the right spot, we're installing our original Marauder engine mounts. Oh, yeah, that figures. Well, just like we suspected, these Flowtech long tubes are not going to work unless we do major surgery to the headers themselves or to the frame rails. So we'll probably end up going back with the manifolds we were running, which may not be that big of a deal. The Cobra manifolds are known to support major horsepower numbers, so I think we'll be okay. Good on my side. Good?
Yep.
All right, from the camera point of view, it may look like the mount's gonna line up with the crossmember. But from where I'm sitting, we're a good 2 to 3 inches from having the holes line up, which is no big deal. We wanted to ditch this factory stamped crossmember and replace it with a tubular one. And that way, we can keep it tucked up in between the frame rails and keep it from hanging down too low, because ground clearance is gonna be pretty important with our new and much lower ride height. And we've discovered one more thing as well. There's a difference between the Marauder oil pan and the Ford Racing Illuminator pan, giving us a few more inches of clearance, allowing us to drop the engine down, lowering the all-important center of gravity. But there are plenty of other things to consider before we start making modifications to get that done. We've got to think about steering rack placement, exhaust clearance, and firewall and hood clearance for our now blower-equipped V8 engine. So we've got to drop the body back down before we get into all of that. But one thing we do know for sure, these factory suspension mounts or pickup points, they're going away. Now the upper control arm mounts came off pretty easily, but the lowers were a bear. They're about 1/4 inch thick and they're double layered. And it gives you an indication of how much more stress the lower arms are under in comparison to the uppers. Ford didn't want these things going anywhere. Hey guys, welcome back to the shop. Well, we've got all the control arm mounts cut off and the top of the frame rails ground clean. Now you might be asking yourself why we didn't utilize the existing pickup points, and it's for a couple of reasons. First off, the suspension kits available for late model Rangers focus more on aesthetics and just getting the truck to sit lower, and we're after precise handling. Plus, doing it this way, we can relocate the pickup points and move the front axle center line forward about an inch or inch and a half like we talked about before. Now, doing it this way is going to take a little bit more research, design, and engineering, but the time investment is going to pay off when this thing hits the track. And as far as components, we'll check these out. Now, the upper control arms are rod end equipped and adjustable so we can dial the suspension in. They utilize screw-in Chrysler ball joints. We attach them to these ball joint adapters we picked up from Whitby Motor Cars, and they allow us to bolt the upper arms to the SN95 Mustang spindle. Now, the tubular lower arms are from Factory 5 Racing and feature greasable polyurethane bushings and a built-in coilover mount. Now, by using the Mustang spindle, well, it gives us access to commonly available and reasonably affordable big brake kits. As far as this nasty hub goes, well, we're going to get a new one on there. This is just for mock-up.
And with our frame all boxed in, it really moves this project forward and allows us to do things like mount our custom fuel tank. This tank came from Rick's Hot Rod Shop's The Rick's Tank Division, and it's a custom-made stainless steel fuel cell that was made based on the measurements that we emailed to those guys. They also sent us some 90-degree bends. That way we can mount this thing at the location and height that we choose. Now, one of the best features of this fuel cell is the fact that it's internally baffled. And since we're going to beat on this thing on several road courses, this is going to take care of any fuel slosh issues that we may have and keep us from starving the fuel system. Now, speaking of fuel delivery, take a look at this. This is our new dual fuel pump setup that's made by Ford Precision Works. Now, this is a great upgrade for the 03 and 04 supercharged Cobras, which makes it the perfect pump system for the arrangement that we've got here. It features two 255 LPH pumps and is fully billet aluminum. And since Ford Precision gives us the option, we opted for a return-style system with a Dash 8 fuel delivery and a Dash 6 return line. And this ought to make sure we're going to feed that hungry monster.
Today, we're converting our Mazda B2500 to the Ford Ranger that it really is.
Ranger!
And we're doing a side-by-side comparison of our frame stiffening. Finally, it's all the speed parts we'll need for our Illuminator engine. It's all today here on Trucks.
Hey guys, welcome to Trucks. Well, today we're back on Project Rolling Thunder, our V8-powered Mazda B2500 compact truck. When we first started looking for a vehicle to start this project, we were actually looking for a Ford Ranger. But we got a screaming deal on this Mazda 2500. And essentially, it is a Ranger. The cab's the same. The doors are the same. Almost every major component in this vehicle is a Ford Ranger. Heck, it even says made by Ford on the door tag. But we're kind of getting used to the subtle differences that make it a Mazda. But we're still going to change it. Well, why would we change it from the Mazda truck that it is, kind of cool looking, into a Ranger? Well, check this out. This rendering was inspired by an actual vehicle that Ford's SVT team put together using an 01 Ford Ranger and a Ford Lightning drivetrain. Now, this truck looks downright mean, and with the power that we've got sitting in the corner waiting to go in it, it's going to back it up, too.
Now, one thing we're definitely not going to change, because it's the same as the Ford Ranger, is this lightweight aluminum hood. Now, the rest of the swap is pretty straightforward. And since these fenders have a few dings, dents, and pop knots, well, it would take a little bit of labor to get them ready for paint anyway. So a sheet metal swap makes even more sense. Now, this would be a great project for you guys to do at home if you've got a Mazda and you want to turn it into the more popular and to some better looking Ford Ranger.
Now, we could always do a salvage yard swap. There's plenty of Ford Rangers in the junkyards, but we may end up in the same position as with our Mazda fenders and a little bit of body work to do. So we went online to LMC Trucks' website, went through their catalogs, picked out some parts, and here's what we got. We started out with brand new sheet metal Ford Ranger fenders. And the one thing that's distinctly Mazda is the header panel and grille. So we got a Ford Ranger header panel that will support everything else. Now check these out. There's lots of headlight options in their catalogs. These resemble our rendering almost to a T and will give us nice bright refraction, and they're kind of cool looking. They've got several options with the grill. You can have a painted grill or a chrome grill. Again, the painted grill resembles our rendering, so we're going to roll with that, although chrome's an option for you guys. Now, the valance panel has optional fog light ducts. What we're going to do is utilize those as brake cooling ducts, since this is going to be a road racer. So the rest of it, just part swapping. Now, it doesn't take much to tear down the nose of one of these trucks. Just a few simple tools will get the job done. But keep this in mind. This truck's old enough so that some of the plastic parts and fasteners, well, they can get a little brittle. So take care taking it apart. Trust me, get a hardware box. You'll thank me later. Now, all the parts and pieces, well, they're very lightweight. And it might seem like these trucks aren't made of much, but just because the sheet metal's light doesn't mean the underlying structure is not. It's made to absorb impact on a collision, and it's quite strong. There's some obvious differences between a replacement fender and the original fender. The biggest one that you see is the fact that the E-coat, or the electrodeposition primer, is black instead of the grayish-green color. And your eyes are drawn right to this sticker. This just signifies that this fender, or this panel, has been certified by the Department of Transportation as being a safe replacement. Now, this greenish-gray E-coat is what the factory put on. So if this is still the color underneath your truck's skin, well, chances are it hadn't been crashed out. Here's what we're doing now. We're going to transfer this clip. Now, there's an easy way to release these J-clips. Just grab a hold of the spring steel tab, just lift it straight up. That allows you to replace it, and it still stays in place. It won't drop off on the floor, and it's still movable, so you can adjust this panel. Now, you can clearly see the difference between the Mazda fender and the Ford Ranger fender, at least when it comes to styling. But the mounting locations are exactly the same on both pieces. We had no trouble at all lining up the panel gaps, and the stampings were precise. Now, you want to make sure that there's no interference between the door and the new fender. This fender passed that test pretty good, too.
Looks good width-wise. For the most part, looks pretty good.
Now, making sure your fenders are properly aligned is the foundation for the rest of the truck fitting well. If the fenders don't fit, none of this other stuff is going to line up, and you're going to be chasing problems around in a circle. So fit your panels from the back to the front. You should be in good shape. Now, some of the parts come with hardware and clips. Some of it you got to repurpose from the old parts that you've taken off. We reused the mounting hardware for the headlights and marker lights from the old ones, such as these spring steel headlight mounting clips. They go in from the back side and hold the headlights in, but they can be accessed from the top. Sometimes it takes some specialty tools, so thanks, Matco. All right. Now, we're using brand new retainers to hold the grill in from the top, but we transferred the spring steel clips for the bottom from the other header and grill. Ranger. Now, with the Mazda front bumper stripped down, guess what? It perfectly matches the profile of the Ford Ranger grille. And that's just proof that there's some crossbreeding going on, and this truly was a Ranger to start with. Now, the lower valance here, like we said, we want to utilize these fog light ports as some kind of brake cooling duct.
Now, it doesn't bolt right up. We're going to have to do some work to it to get it to work. But we wanted to build a chin spoiler or a splitter anyway. So we've got fabrication work ahead of us no matter what we do. Now, for the minimal time and money investment we've got in this thing, well, we've turned our plain Jane Mazda B2500 into a late model Ford Ranger, and a modified one at that.
Up next, we'll show you just how much difference frame reinforcing can make. And later, everything you need to make an easy 600 horsepower. Stay tuned.
Hey guys, welcome back to the shop. Well, now that we've got 95% of the boxing done to the frame rails of our Ranger, well, we wanted to take a few minutes and show you what adding about 10 pounds worth of 1/8" plate steel can do to the overall stiffness of the chassis. Because if you remember last time, This frame was way too flexible for the use we have intended for this truck, with a good 2.5 inches of flex on the frame before any of the other frame points lifted off the jack stand. And now we've got that number down to about 3/8 of an inch. And that's before we add in the roll cage. And it's without the rear bumper and spare tire carrier holding the rear frame rails together. And with the stiff chassis not doing much flexing or twisting, our coil springs on the suspension will be able to do their job much more effectively. It's quite the drastic comparison when you stack them up side by side. Now, we've also done some modifications to the front section of the frame. We've lopped off the factory rack and pinion mount, as well as got rid of the coil spring pocket and shock mount, along with the upper and lower control arm mounts. Then we just welded in some 1/8-inch plate along the side and capped the holes at the top and the bottom of the frame. And that'll give us some good flat real estate to work off of when we're building our custom front suspension. Speaking of which, if you're doing a project like this at home, make sure it's planned out and it's going to work correctly. The last thing you want to do is just wing it. Could end up in the ditch. Now, if you're going to do this, try to avoid the trial and error method. Not only wastes time, it wastes materials. So for a better alternative, check this out. This is suspension analyzing software that we got from Performance Trends. These guys have software applications for circle track racing, engine building, drag racing, and a whole bunch of others. Now, what you have to do is measure out your frame, plot where you think your suspension pickup points need to be, enter the information into the software, it makes some calculations, and gives you something like this. Now, this may look intimidating, but just some of these values are inputs. The computer software actually does a lot of the work and calculations for you, providing a lot of the outputs. Once you have all your information entered, the software will provide you with a great visual. It will allow you to see a front view, side view, as well as a top view. You can even go in and animate and simulate different suspension dynamics, such as dive, steer, and roll. And that'll let you see what kind of changes you get in the toe-in, camber, and caster, and roll center height. And doing it this way, you can make sure your suspension is working like you want it to and all dialed in. And that's before you even cut out the first bracket or lay down the first weld. Definitely a time saver. Now, we're not done with the suspension software yet. We still got to figure out steering rack placement and a couple of other small things. Now, what we've done here is assemble our front suspension. We've got upper and lower control arms, our ball joint adapters, and we went ahead and attached them to the spindle. Then we just welded this jig to our sacrificial hub at a height that mimics the center of the front wheel. And by placing the jig parallel to the front axle center line, setting the frame at ride height, and picking out our front axle width, we can come in here and determine if we're going to have any interference issues with the front control arm mounts. Now, by doing this and using the suspension analyzing software, we can make sure this is done right the first time. And any fine-tuning that needs to take place can be done utilizing our adjustable suspension. Now, I guess we just need to make it happen, but that's another day.
Hey guys, welcome back to Trucks. Well, with the solid plan on our suspension well underway, we wanted to talk to you a little bit about the engine swap that we're doing. Now, there's no doubt that there's great aftermarket support for these 4.6 modular engines, in particular from Ford Racing with our 4-valve Illuminator engine here. But you got to keep this in mind. These manufacturers are doing these projects and these products as upgrades, and they're assuming that you either have a core or a complete donor, and that you're going to upgrade using their parts, and that they may not have every single thing that you need to do the swap in their catalog. Now, this upper idler pulley bridge and this AC delete pulley, well, they are from Ford Racing. I'd suggest that you go to Ford Racing's website, search their catalog, see what they do have, but there's some things that we know they don't. Now, you might just be surprised as to how many of these parts are still available at your Ford parts counter. The engines are new enough and popular enough to where they may have replacement parts in stock, or they can find them through their distributors. The issue is that sometimes over the parts counter, the dealership can get a little bit spendy. So you can do what we did. Surf a bunch of Ford performance-specific forums like StangNet, like SVT Performance, and Modular Fords, and find a guy, just like we did, that's swapping from his root-style Supercharger to a turbo system. And he's got all his swap parts available, like the charge cooler, the lower intake, coolant manifold, the IC coolant pump, which is, by the way, the same for the Lightning, so you can find one on a Lightning forum as well. All the duct work and coolant routing, including the lower cage pulley. My point is this: you're going to have to do some digging and hunting around and swap meeting to find all of this stuff, but hey, that's kind of fun anyways. And once you do have all of the pieces that are going to make up your Terminator and all the accessories, then the aftermarket kicks in. You can turn the wick up. Now, you can pick up a stock Eaton Supercharger for a Terminator all day long. Fairly reasonable. And that's because most of the serious Cobra guys are upgrading to this bad boy. Now, this is the Whipple 2.3, which incidentally is available from the Ford Racing catalog. They give you a choice of an upper pulley. And for a throttle body, we decided to go with this AccuFab single blade throttle body, which gives you 70% more airflow, almost 1,700 CFM of airflow. Now, this setup is capable of nearly 20 pounds of boost. So to keep up with those extra atmospheres, you got to give it enough fuel. We're using 4 Precision Works beautiful billet fuel rails, their fuel pressure regulator, and their fuel pump hat that we showed you earlier. Now, since we're beefing everything else up, we certainly didn't want to compromise on the transmission. Now, we wanted a 6-speed, but a stock T56, well, it's rated at 450 foot-pounds of torque. This Magnum T56 rated at 700 foot-pounds of torque. Now, there's typical Tremec options, like the choice between a mechanical and electric speedometer sender, but the coolest thing are the multiple shift locations. You can have one on the transmission body and this reversible on the transmission tail shaft housing, giving you 3 different shift locations and lots of different options. Now, the Magnum T56 is essentially an aftermarket version of the TR6060, which is the same transmission found in Shelby GT500 Mustangs, Super Sport Camaros, Cadillac CTSV, SRT8 Challengers, and Z06 and Z71 Corvettes. So if it's tough enough for those high-performance platforms, it's going to do just fine in our little Ranger.
Hey guys, welcome to Trucks. Well, we finally have the front suspension mounts nailed down and welded in where they're supposed to be on the frame for Project Rolling Thunder. And we want to show you all that. But we've done some other stuff as well. We've relocated some mounts, added some boxing and some gussets, and just kind of did some more finishing work on the frame, meaning we're just about ready to add some parts to this thing. But we want to show you everything first. Now, we had to make a pretty serious relief cut in the frame rail for the upper control arm on the independent rear suspension. And that just didn't leave a whole lot of frame rail left. So we boxed it in to add some strength. Now, this rear section of frame rail, well, it doesn't have to be that strong, but we still wanted it as stiff as possible. So we added this 1/8-inch thick reinforcing plate. It's got a complete perimeter weld, rosette welds, and we contoured it to fit the frame rail. It's also got fish mouths at both ends. Now, the reason for the fish mouth is twofold. It not only gives you more area to weld to, making it stronger, but it eliminates a straight seam with stronger metal on one side and weaker metal on the other. If you did it that way, well, it'd only make the metal easier to fatigue and crack. Now, the name, well, it's pretty obvious. Looks just like a fish mouth. And this one looks like a carp with an underbite. And this one here is definitely a hungry largemouth bass. Now, we told you before we were going to have to build a new transmission crossmember for our T56 Magnum 6-speed. We also told you we didn't want it hanging below the frame rails. And we've got a gusseted pad for our polyurethane transmission mount. We used a piece of DOM tubing, a dimple-dyed gusset for strength, and we welded a bracket directly to the frame rail that will allow the crossmember to bolt in and be removable. And since it ties the two frame rails together, well, it's going to add some strength as well. Now, our new 4.6 kind of has this giant blower sitting on top of it. So we wanted to lower our engine and transmission down into the frame rails about 3/4 of an inch for hood clearance, because we want to keep the stock hood. And that meant new engine mounts and a relief cut and boxing of the crossmember for oil pan clearance. We've got about a 1/2 inch in between the pan and the crossmember. Now, we also boxed in the relief cut we made on the frame for manifold clearance. Now, there's no two ways about it. Designing a completely custom suspension system that works well is a challenge, and that's an understatement. In fact, these control arm mounts that you're looking at, well, that's version 2.0. The first edition worked great on the computer and in theory, but when it came time to applying it to our pickup truck frame, well, it just didn't work out so well. The steering rack was hitting the crossmember, the oil filter, you name it. It just flat out wasn't going to work. So what we ended up doing was putting the steering rack where it would work and designing the rest of the control arm pickup points around it. Now the lower control arm mounts are made out of 1/4-inch thick steel and welded solidly to the frame. The lower arms are from Factory 5 Racing and fit a Mustang. The upper mounts have 2 holes for adjustability. They're made out of 3/16 plate and attach the circle track upper A-arms. Now we had to ditch our stock Ranger rack and pinion. When we built our custom front suspension, we built it to match the increased track width of our independent rear suspension out of an 04 Mustang Cobra. So bottom line, the Ranger rack just wasn't wide enough. So we picked up a steering rack from a late model Mustang to suit our needs. Now our steering rack bushings came from Maximum Motorsports, and they're solid anodized aluminum. They offer multiple mounting positions, so we can try to dial out any bump steer, or we can move the rack slightly if we've got any slight clearance issues. Now, since they're solid bushings, well, we're going to get all the feedback that the road's going to give us, but that's a good thing on a performance truck like this. And the trade-off for a little bit of extra noise and vibration is well worth it. For tie rod ends, we're going to try to get away with using these Mustang ends. But if need be, we can upgrade to an adjustable rod end later. Now, when we were planning the front suspension, one of our goals was to minimize bump steer. Now, in case you're not too familiar with what bump steer is, here's a brief explanation. It's what happens when the suspension and steering linkages move in different arcs. When that happens, when the suspension compresses, it can actually induce unwanted steering into the front wheels. Not what you want. Now this is more suspension travel than our truck will ever see, but it clearly shows a change in steering without any input from the driver. Now what we're going to do to minimize bump steer on our truck is to make sure that the pivot points of the inner and outer tie rod ends line up with the pivot points of the lower control arm, both at the frame and out at the spindle. Now if we can't get the steering linkage and control arms to move in a parallel arc by adjusting the rack bushings, well, we'll just pick up a bump steer kit for the outer tie rod end. And that way we can change the height of the pivot point of the tie rod and get our pickup truck to handle as predictably as possible.
Yep. There it is. Hey, welcome back to Trucks. Well, now with the front suspension done, we can lower the engine and transmission into our relocated mounts and get this thing a little closer to a more complete rolling chassis.
Now, our front suspension is nearly complete, but we still got to pick out a front sway bar and coilovers for all 4 corners. Now, like we told you earlier, suspension design and geometry is a very complex subject because there's so many things to consider. Steering axis inclination, camber gain, caster trail, bump steer, roll center, scrub radius, and Ackerman angle, just to name a few. So needless to say, it's complex, and it's nice to have an expert kind of check your work when you're doing something like this. And that guy for us was Jack Hidley at Maximum Motorsports. He's been immensely helpful in making sure that this is done correctly. So whether you're doing something like this, or rebuilding your first engine, or laying down your very first paint job, it's always nice to have an expert in the field to kind of help you through the process. Now, speaking of Ackerman angle, that's the reason why we had to redesign our original front suspension setup. There just wasn't enough Ackerman angle built into the steering, but we've got that all taken care of now. And if you're not familiar with the term Ackerman angle, well, here's what it is. Now, if you drew an imaginary line perpendicular to each front wheel while it's turning, and they intersected on a line drawn straight out from the rear axle center line, you would have 100% Ackerman or geometrically perfect Ackerman steering, meaning that the outside tire is going to follow a larger arc or a larger circle than the inside tire, allowing the vehicle to pivot around the corner without these 2 front tires fighting each other. Now, if the steering tires were parallel and they followed the same large arc, well, they'd be fighting each other for traction as you went through the corner, causing tire scrub and other unwanted handling characteristics. Now that we know that, Well, there's two different schools of thought on how much Ackerman angle you need built into the steering of a race car due to the outside tire handling the vast majority of the cornering load and the inside tire kind of being along for the ride. But we're not building a race car. We're building a fast street truck that we can take to the track. And making sure we have the appropriate amount of Ackerman angle built into our steering will ensure that our truck handles great on the street and at the track.
Now, the front suspension system is a mixture of aftermarket and original equipment components, like these front seal bearing hubs that are spec'd for an SN95 Mustang. Now, they're easy to replace and inexpensive, and also support aftermarket brake upgrades, like these Brembo 13-inch rotors with 4-piston calipers that we got out of the Ford Racing catalog. Because at the end of every straightaway is a curve or a retaining wall that we frankly do not want to come into contact with. And the last piece of the drivetrain puzzle is the driveshaft. Now, a great way to reduce weight and parasitic drag at the same time is with an aluminum drive shaft. So we called Denny's Driveshaft service and had him make us up this one. It's his 1350 series high-speed balanced 4-inch aluminum shaft and features Spicer 1350 series U-joints and this forged Spicer slip yoke. Now, we told Denny we were going to be pushing about 600 horsepower out of the back of this transmission, and we needed a shaft that would handle it. Well, he built us one that would take double that punishment. So it doesn't matter what you're building or what you're building it for. Go to Denny's Driveshaft's website. He's got all the forms and all the information that you need to submit an order for a drive shaft that can handle anything you can throw at it. Hey, welcome back. Well, you guys knew that we had a Rick's fuel cell that we were going to put behind the rear axle. We didn't know exactly where until we mounted the IRS cradle. Now that that's done, Ryan has done a nice job of installing some captured nuts on the inside of the frame rail, so we've got a way to lock it down. Now, Rick's also sent us some 90-degree angle brackets that we've TIG welded to the sides of the fuel tank. That way, we can locate this thing exactly where we want it. Now, we also told the team at Rick's that we wanted the filler neck centered in the gas tank. That way, we can route it up through the bed floor and use a flush-mounted filler cap. We're also going to take advantage of the vacant real estate in front of the IRS cradle by mounting our battery and our coolant reservoir for the Supercharger back here. Now, battery, typical hot rod stuff, we get it out from under the engine compartment and closer to the rear axle to help with weight distribution. The coolant reservoir is going to help us in a couple of different ways. Number one, it's going to be a larger capacity than the factory unit, and with the distance between the tank and the Supercharger, we get better heat dissipation, better cooling, cooler running temperatures, more power. We made some calculations to show you guys what kind of difference you can make just by rearranging some of these components. The fuel tank itself weighs 54 pounds. 16 gallons of fuel at 6 pounds per gallon weighs an extra 96 pounds. This gives us an extra 150 pounds behind the rear axle. Now, our battery is going to weigh 45 pounds. Our coolant reservoir is about 20 pounds, and we picked up an extra 100 pounds just with the IRS cradle. That gives us a redistributed 315 pounds over and behind the rear axle. Now, you combine that with what Ryan's doing with the front end, lowering the roll center, stretching the wheelbase, well, that's getting us closer and closer to that 50-50 weight distribution we're dreaming about. Now, we want to create some protection for the fuel tank, just in case somebody runs into the back of this truck on the street, or in case sometime on the track it swaps ends and heads for a barrier. So we're going to build a protective cage around the fuel cell.
Now, this protective hoop is just 1 3/4 120 wall DOM that we bent up using our JD squared bender. Now, we designed it to sit rearward of the tank and lower than the tank. That way, like Kevin said, it'll protect the back and the bottom. After all, we don't want to scar up all the nice stainless steel. This truck is going to sit pretty low. And after mocking things up on the frame rail, we cut it loose so we can do the final welding on the floor. Then, after cleaning up the frame rails for a good clean weld, we tacked it in place again. Then we removed the fuel tank so we could get this little project finished up. Watch your fingers.
Perfect.
A Lakewood Driveshaft safety loop is another part we're eventually going to be installing. And if you're doing some racing, well, it may even be required by the sanctioning body. It's a universal fit, will fit a variety of different cross members or frame rails, and with it being made out of thick 1/4-inch steel, well, it's more than capable of containing the drive shaft in the unlikely event of a U-joint or drive shaft failure. The last thing you want is some 5-foot drive shaft finding its way up through the floorboard unexpectedly. Hey guys, welcome back to the shop. Well, Project Rolling Thunder is coming along nicely. We got our complete drivetrain installed, and the body is back on the frame where it belongs. And this truck's sitting at ride height too. And I gotta tell you, I think it looks downright aggressive. We're both really happy with the way this thing is turning out. Now the pegs you see holding the frame up at ride height are gonna go away as soon as we can get our hands on some coilovers. For now, we're just happy that the suspension is basically done. And from this angle, well, looks pretty good. But from this angle, it's pretty clear we'd have a major tire rub if we don't do something about this fender. Now, I guess we could come in here and make a relief cut and bring this arch more towards the front. But we've got another problem as well. And it's this ½ acre of real estate in between the tire and the rear of the fender. Now, the reason for that is that we moved the front axle center line forward 5 inches from here to here. Now, we were originally going to go forward 1.5 inches and not do any body work. But if you remember, we had to build the front suspension around a suitable steering rack location. But there's another benefit to that. Now we've got 90% of the engine and all its weight behind the front axle center line, helping us with the weight balance. Now I guess it's up to Kevin to come in here and work some metal magic and try to get this straightened out. And whatever he does and comes up with, well, I'm sure it'll be functional and look good.